Good morning, sir.
Am I audible?
Yes, sir.
Good morning.
Good morning, sir.
Good morning. Am I audible clearly?
Yes, sir.
Okay, so starting. Good morning to respected eminent speakers, organizing team, and participants. Welcome to the third day of the 5-day online faculty development program on recent trends in civil engineering, organized by Department of Civil Engineering, Haldia Institute, NIT, Durgapur. Sir has earned his BE in Civil Engineering, Masters in Structural Engineering, and PhD from Jadavpur University, Kolkata. Dr. Samantha is the recipient of the esteemed Overseas Research Student Award from CVCP UK. Prior to joining NIT Durgapur, Sir was associated as Senior Design Engineer in the Stoop Consultants Limited. Professor Samantha's current area of research interest includes constitutive material, concrete modeling, mechanics of concrete structures, development of new innovative materials, evaluation of residual life of structures, and damage assessment strategy. Dr. Samantha has published around 90 technical papers, which includes international, national journals and conferences, besides being a reviewer of a number of SCI Index journals. Sir has served as a visiting faculty in CEE Muscat, Sultanate of Oman. Doctor Samantha has extended his expert consultation to a number of important projects, to name a few: AIIMS Kalyani, Agartala Airport. Presently Sir is also the coordinator of Center on Biomedical Engineering and Assistive Technology (BEAT) NIT Durgapur. On behalf of entire Civil Engineering Department of Haldia Institute of Technology, I welcome you, sir. We are thankful to you for accepting our request and gracing the occasion by your presence. Over to you, sir.
Okay, thank you, Dr. Rajbangshi. It's really nice. Thank you so much for your introduction. I'm, in fact, very happy to join your program this morning. Um and I'll just share my PPT and then I'll start talking. So just allow me to share.
Yes.
Sorry. My screen has been shared.
Yes, sir.
Okay. So, this program, I suppose, this is very essential for all of us in a sense that this actually
PPT
helps
का open
us.
होएगी ना? PPT का open.
Has it been shared? My
Sir, the PPT is not
has
visible actually. Only the screen is being shared.
okay. Just a minute. Why it is so? Now it's visible. Hello.
Yes, sir. Now it's visible, sir. It's
Okay.
okay.
Okay. Thank you. So. This is actually required for all of us because we need to understand the environment where we are and actually and so that we can perform the best from our end. So in this regard, my topic of talk is whether we can develop some product which is a little bit away from the construction field, not directly with the construction field, and with the industrial waste. Okay, and as usual, I have a few slides regarding myself, although I have been introduced nicely. Basically, I did my schooling from Ramakrishna Mission Boys Home High School, Rohoda, and then Ramakrishna Mission Vidyamandir, Velur Mott. And subsequent to my technical education, I have worked in the industry for a few years, and then I have joined the academics. And I'm also I have got the membership, fellowship, and life membership in good institutions like Indian Concrete Institute, INSDEC, and so on. And also I have performed several positions of responsibility in my institute, including handling the Department of Right to Information Act, that is called ACPIO. And also I am associated with formulation of the guidelines, particularly for the purpose of the procurement in the institute level and also allocation of space institute wise. Okay. Uh, uh, a sincere word of appreciation goes to the Department of Civil Engineering, all my faculty colleagues, and also the HIT management, including the chairman, principal, registrar, and the dean, as well as the HOD Civil Engineering, along with my mentor, Professor Shomnath Ghosh, who is now currently the emeritus professor in the institute. Uh, I'm really very happy to for inviting me for delivering the talk in this program. Okay. So actually, I have divided my talk into three parts. Okay. So part one is basically uh, what is all about the refractory industry, how it is going to help us in developing our state, in developing our country, and what are their basic products. And second part is basically whether there are different type of waste materials can be used for developing those products, and with a sense of cleaner production in the background in the mind, because nowadays probably every one of us are aware of the carbon footprints and its contribution towards the global warming and the climate change. So that is also a very important aspect. I suppose that I have included this part in this topic of discussion because Nowadays it is not only the academics, it is also the research profile which is important, particularly for the faculty members who are in the academics. So for them, very frequently they are to perform some of the experiments, research works, investigations at research level, or maybe at master's level, or maybe even at the BTech level as well. Nowadays, in fact, our BTech students are also participating very nicely in the research programs, and they are showing their keen interest even from the second year, third year. So before we go for or taking up those kinds of research works, right? One component of this is to prepare a write-up for this. So while preparing a write-up, this is very important that the background of the write-up and the significance why I'm trying to do this work, that's very must be clearly stated. So until and unless that is clearly stated, right, the quality of the write-up will not be cannot be justified. Okay, we may have done a lot of works, we have done a lot of experiments, we may have a lot of results, but if it is not properly grounded with certain kind of motivations or certain kind of development in the current scenario, right? So it will not be very important. So that's why I have included this part of the cleaner production. Okay, and the third part is basically how we have performed a small experiment in regard to developing some of the refractory products. So that is the third part. Okay, so straight away I go to the part one, the refractory industry. So if you ask me that why I have leaving the the civil engineering community in general, why I have taken up this refractory industry as a part of my research work. The background is very simple. In the very beginning of my academic profile, or maybe a little bit after a few years, I got an opportunity to work for MSME sector, which is micro small industry sector by the government of India, and they also launch various projects across the country. Now, in one such projects, I was connected where I did some, need assessment survey for this refractory industry in the Asansol, in this belt of the Poschim Bardwan district. Okay, so that gave me some opportunity, some exposure, and also I was studying their how they are developing the products, what are the components, and what are the procedures, what are their difficulties. And while dealing with them, I got this idea that probably we as a civil engineer also have some scope to work in that field, and that has encouraged me to get into the field. Okay, so just a brief background regarding the refractory material. A refractory material is basically a particular type of product which retains its strength at high temperatures. Okay, so like if you look at the ceramic industry, there is also an industry called ceramic industry. They are all their product are also not in the line of refractory, but certainly similar to in similar directions also, but in a different way. Okay, so like here in this case, we'll only look at the refractory material which are very highly heat resistant, basically. Okay, and they uses the ingredients like molybdenum, tungsten. Okay, all these materials are being uh, part of this refractory product, and they have melting point above 2000 degrees centigrade and very high hardness, and also they are chemically inert. So these points must be kept in mind. And another important point is that they are very much stable against the creep deformation at high temperatures. Okay, these products are particularly used for the steel industry. steel making industries in the blast furnace as a lining material, where molten steel are being are going to take out from the furnace, and that they flow. If you have visited some steel industry, you can see that like water, iron flows over the refractory materials. Okay, so mainly the steel industry, glass industry, and cement industry, they uses this. And while I was performing this survey in this part of this district, I have seen that not only that they are only supplying these refractories to the steel industries in our country, but also they are importing this refractories outside India, particularly to China and other parts as well. Okay, so a lot of entrepreneurs are working, and they are really bringing a lot of economy to the state, to the country, to this part of the industrial belt. Okay, and if we look at the history of this industrial belt, based on the steel industry, and then gradually other industries has developed. Similarly, to support them, this refractory industry has developed across, Maithan, Purulia, even in our Bardwan district as well. Okay, so the popular refractory products are basically fire clay bricks, which has got high alumina content, and then acid proof bricks, as well as insulation bricks. For the chimney, we use inside the concrete shell, we use the liner material, which is basically this insulation bricks. Okay, to control the temperature for the flue to the ambient atmosphere. Okay, so that the concrete gets also concrete life, or the durability of the concrete can be improved. Okay, so these bricks are not only used for the steel industry, but also for some of our civil engineering structures as well. Okay, so there are different types of nozzle bricks are also there. I'll share picture with you. So they are being manufactured in the refractory industry. Okay, so these are very common refractory products. If you can look
Sir,
at.
sorry to interrupt. Are your slides changing or it is on the first slide only?
No,
Which
now
I,
I'm on eighth slide.
no, sir, the slides are not changing in the presentation, sir. Maybe, sir, the sharing of entire screen will help. Means
Just a minute.
not only tab. You may share the entire screen.
Okay, let me
Now
check.
it's showing that when it's a shorter version of the slide, it shows, but when it's in full screen, it's not changing, I think.
Just confirm me once again.
Okay, sir.
Now it is slide 8. Now this is slide 8. Now it is
But
going
it's
back
not full
slide
screen, sir.
slide. It is
It's
going
not
to.
full screen.
It is not
It's slide
changing.
8, but not full screen.
Okay, okay. So I may have to change the mode of sharing.
Yes, sir.
Just a minute. Now it has come.
Sir, the net is slow.
Changing. Change,
Will maybe come.
changing. It's
No, sir, the
changing.
presentation is not at all showing.
Presentation is not showing.
You may share the entire screen while presenting, then it may show. Yes, sir, now it's showing. But yes, sir, now you full screen. Yes, sir. Okay. Can you kindly go one? Yes, sir, it's changing now. So now it's in eighth slide. Ninth, sixth,
Okay.
five,
So I think
four.
this is
Yes,
the
sir, yes.
first thing from where I have started.
Yes. Thank you, sir.
Okay. So this is. I repeat briefly. So I have divided my talk on three parts: part one, part two, and part three. One is how refractory industry works. Part two is how we can have the industrial waste uh, blended in the refractory products. and towards developing a cleaner world. And the third part is experimental investigation. So this was I was sharing regarding the basic of the refractory products. What is it actually? And then finally, these are the some of the pictures which I collected personally while visiting the sites of the various refractory industries. These are all like different types of products used for different applications. This is also like you can see here, there is bricks, fire bricks, this part, and the other parts are with some of the nozzles, okay, different shapes, castables. So if you look at the products, basically uh, the raw materials which are used for the developing the refractory products are basically some of them are naturally occurring and some of them are synthetically prepared. Okay, naturally I means plastic, non-plastic clay, bauxite, dolomite, chromite, like all these things are base raw materials, and along with them there are certain materials which are infused. They are basically mullite and alumina products, different type of, and silica as well. Okay, so these are the raw materials which we have seen. This is of course this on the right hand side. This thing is basically this is waste refractory products which sometimes they are also using for preparing the face products. I think they're recycling rather. Okay, for preparation of the refractory products. Okay. The process for the manufacturing is the raw materials are collected in the vat, then they are crushed and grinding is being done. Then after screening for a particular size, then they are mixed. Basically, this is a dry mixing procedure, and they use hydraulic press for pressing the brick or different shapes, and they are dried, and then they are being fired in different type of kilns. Okay, and they're cooled. After that, there is quality inspection, and finally the products are being packed and used sent for the different industry. Okay, this is some kind, in some sense, you can say for civil engineers, the way we prepare the clay bricks. Okay, nowadays, in fact, we are also preparing the fly ash bricks. In a similar way, but of course the raw ingredients are different and also a little bit difference are there because of the mixing procedure, dry mixing procedures. Okay, so in terms of the figures I have shown, in most of the industries I have seen their entire process is either automated or semi-automated. So these are the basically crushers. So the raw materials are basically crushed into small sizes with using the impact crushers. Then they are being kept stored in batches, and then sometimes depending on the type of the ingredient, they are also grinding is being done using jaw crusher, and then sieving, pulverization is done manually or using semi-automatic. Then finally, after this mixing is done, then there is a important procedures which is being carried out. I think this thing we have heard also. This is called magnetic separation of iron particles present in the ingredients. uh, this is done using a magnetic separator. This magnetic separation is also very essential, particularly who are using the different type of slag materials for developing the construction, construction materials like concrete and so forth. Okay, so the iron are being taken out from the mixture. Okay, then they are weld, and sometimes hand molding is also done, okay, using die. And the 7B pictures, it describes the hydraulic press machine where they are being done, using mechanically. The different type of refractory products are prepared. Then it is being kept for drying, and then it is charged, keeping inside in a clean. Okay, this clean basically you may have seen there are different types of clean. I'll name a few. There are different types of tunnel clean, or uh, where the samples are being arranged in a particular order so that firing can be done in uniformly. If you look at the the products, final products at step number 10, you can see that the color of the products are different depending on the firing temperature or non-uniformity, unevenness in the firing procedure. Okay. So here basically I have mentioned the sources, from sources the materials are being collected, then they are transported and storage, and they are being treated also. Sometimes the treatment is required, sometimes because the entrepreneurs or the industrialists who are preparing the refractory bricks, they sometimes fail to take care of the raw materials. They are being kept in the open air, and sometimes for a long time. So that's why before producing the refractory, the appropriate treatment is necessary, and that is where also it was an important note by the team who were visiting this industry, that it requires some kind of intervention to maintain the quality of the final product, because they are also importing the products as well. Then there are certain issues with different type of cleans. Chamber clean, probably you might have seen if you have visited an industrial area. Chamber clean is very popular, and it looks like a dome where people enter through one door and arranges the dry products, and then it is being fired. And the modern clean is basically the tunnel clean or the shuttle clean, which is basically it is something like there is railway, small railway line is there, and there is manually operated carts are there on which the products are being arranged, and they are taken inside the clean, and then by closing the door it is being fired. Okay. So here what we see basically, that these refractory industries, they are very very old, and they are basically they have developed in this area because the raw materials are available because of the presence of the mines nearby places, and also there are skilled people also there at cheaper rate, so that's why they have developed lot of refractory industry, particularly in this part of the world. Of course, Tata Steel, they have their own refractory unit, which is known as the Tata Refractory, and probably the plant is very big and almost automated plant, and it is probably situated at the Kharagpur area. Okay, maybe a little bit away from the city. Okay. So this refractory industry is very important, for our country, for developing the economy, as well as since they are very insignificant in size. So they sometimes they do not get appropriate attention of the government, and that is why sometimes also the different type of industry, they suffer because of this refractory industry. Although their product is satisfying a part of this manufacturing process of the steel industry, but still it is very important, and for getting the final things out of the reputed industries like steel and cement, aluminum, etc. Okay. So in our in this Durgapur Raniganj area, I hope everybody has heard the name of this company, Ban Standard, which was set up at Raniganj in 1874, and they basically first set their this refractory manufacturing unit, and after that gradually there are a lot of industry in this field has come up. And this figure I have just shown you, that exactly which location the refractory industries are lying. They are not in part of the East Bardwan, but they are basically around the West Bardwan and a part of Purulia, Bankura as well. But I have not included this picture where exact units are located. This is just to give you an idea where they're basically operating. So this is one important issue which we found particularly for these industries, and probably you can also feel while you will be traveling in that particular area that lot of air pollutions are being contributed by this refractory industry, and also they contribute to noise pollution as well. And this type of noise which is being generated also affects the livelihood for the the laborers, for the people who are residing in that place. So there, it's now has become mandatory to add some kind of the noise control device and pollution control device. Some of the big refractory house, like I can remember the name. I think it is National Refractory at Maithan, and similar other big refractory house. They have included all these units in their manufacturing procedures. Another interesting thing I also found that some of the refractory industries, like in Baraboni, Mithani, this area, which is very close to Chittaranjan, they are using not coal as the fuel for this running this kiln, but they are using coal fired gas. So they have an ancillary unit which is added to their industry, where they are using coal as a raw material to develop the some kind of fuel, and that fuel, oily fuel, and which is being used for firing purpose. That is very nicely I have seen, and that particularly contributing a lot towards this controlling the pollution in the area. Okay. So some of the analysis I also did, like the what is their strength, how they are contributing, and their opportunities in this field, and how they are going to be a threat also to the countries and the refractory market all over the globe. Okay, this may not be very important for us as a civil engineer, but still I included because if they survive, the industrialization also grows rapidly. So industrialization is also linked to growth of this refractory industry. So that's why I just included these points. I'm not going into the brief discussion of this. And certain issues I would like to point out that there are basically different levels at which the difficulties are there for the growth of this MSME sector. So one is unit level. I means that individual, unit level deficiency. Then there is a cluster. I mean, cluster, you can say, like there is a group of refractories which are operating together, or which are sharing facilities. Like, say, for example, once the refractory is manufactured, it has to be tested. Okay, so for testing facilities, for developing the testing labs, if every company, every unit is going to develop such facility, then it requires a lot of time. So it may not be that easy for each of the units or at the unit level. So that's why sometimes they form clusters with a group of companies, and they wish to have certain facilities at the group level, at the cluster level. And also there are certain issues at the national level. Sometimes they were also telling that they have also some issue with the availability of the fuels. Sometimes they do not get also fuels very easily. Although we have in our area, particularly in the east west part of the Bardwan, we have a lot of coal mines, but they complain that many times it happens they do not get the regular supply of the fuels, because of which their production is also going to get disturbed. Okay, so this is a picture which actually explains about the market share of the refractories all over the India. Okay, for the reputed brands. So if you see that the Tata Refractories has got almost 16.6 percentage of market share in the refractories. Similarly, if you see Mithun ceramics, it is also there, and I suppose they have a good, good contribution. That is in terms of around 19.1%. So here, what why I have included this figure, because from here we can come to know or understand that how the entrepreneur or the company is big is in contributing towards the industrialization, particularly for the countries like ours. Okay, so this is an overall picture, okay, regarding this, and this was collected from the Refractory Manufacturer Association's report. Okay, and this is a global market, and as we can see that there is a upward trend in the demand of the refractory products in our country particularly. And this is the scheme what I was talking you about, where I was a part of it. This is known as the design clinic scheme. Considering the entire cluster, right? How some of the parameters of for these entrepreneurs can be designed so that they can there is a, holistic development in this cluster. Okay, so regarding particularly the skill upgradation of the laborers, or maybe the managers, or maybe the company owners. Okay, so those opportunities and are to be identified, and particularly we also arranged for workshops to deal with them, to talk to them what is their difficulty at different level, financial level, and the like collecting the raw materials and the products. So this exercise was done, although around 10-15 years back, but now we, as a civil engineer, I have draw on lot of nourishments in terms of developing the construction materials. So initially I was thinking whether it would be really helpful for me as a civil engineer or not, but later on find that it has got a lot of potential in getting the opportunities for developing the construction industry as well. Okay, so I go for the next part of the talk regarding the industrial waste versus cleaner production. Mm, you know, uh, First thing is, if we look at the globe, what are the current issues that coming up? That is that the temperature of the globe is increasing at a very higher rate because of the carbon dioxide emissions over the particularly the industries from the developing countries or the developed countries. Okay, so that is why there was a summit long back, and that we know that is known as the Kyoto Protocol, which was signed in 1997 towards the reduction of the carbon emission, and also some of the regulations were formulated from that Kyoto Protocol. But unfortunately, this is not contributing towards that direction in a very uh, you know current means to control the CO2 emissions. Okay, so as a civil engineer, we are aware that we require cement, and that production of the cement adds CO2 to the atmosphere. So one target is to reduce using cement consumption. So how we can replace cement with some other kind of materials? So that remains a issue, where by how by the procedure how we can really control this particular CO2 emission to the atmosphere, ambient atmosphere. So that is one important thing, and here there is some reference which I have quoted, that 1 ton of Portland cement clinker production is said to create approximately 1 ton of CO2 and other greenhouse gases. And these environmental issues are playing very important role for sustainable development of the cement and concrete industry. In fact, that in the cement production, we are also using some kind of other materials, so that not only the economy but also the utilization of the waste materials, that is also being coming into the picture. So here there is a overall picture throughout the globe, where the emission of the carbon dioxides being, in terms of the percentage, globally has been depicted, where China has got the highest contribution towards the CO2 emission, and then United States, then European Union is 10%, and India and Russia has got almost 6% of the contribution towards the CO2 emission. And Japan has got, of course, much lower, and the other countries all over the world they have. So this picture actually shows us that how everyone should take control of themselves, and particularly in regard to the rapid industrialization or participating in the industrialization procedure. Okay, so this is now a very important buzzword in our newspaper news channels, that is called clean sweep. I don't know whether you have heard about it or not. And they mostly talk about being carbon neutral by 2030 and carbon zero by 2050. I think it is also in this regard some kind of determination has also been taken by the government of India. What is meant by carbon neutral means that whatever carbon dioxide emissions or the footprints that we are producing, it should be made half by 2030, and it should be bring down to zero by 2015. And this is very important because of the uh, climate crisis, and also regarding the fact that the planet is changing in a very erratic manner. Okay, so what I was talking, that the global average temperature is rising by around 1.5 degrees Celsius uh, every year almost. And so at a high pace, the temperature is going to increase very globally, because of which we are much concerned. So that's why the finger has been shown towards the industrialized nations, so that they can control this emission of this greenhouse gases roughly half by 2030. And in fact they should stop adding this by 2050. Okay, that is the target that is being taken by many of the countries. Okay, so here one one write-up I was going through very recently, that has come up in the news channel as well, that even if you look at the IT sectors, uh, they are also producing a lot of hazards, lot of wastes. They are also trying to recycle their waste materials, particularly for the developing the e-gadgets. Okay, and they are also contributing towards the growth of, although they are contributing towards the growth of the technology, but they are also, in different stores where they have manufacturing units. They are not only producing the industrial waste, but also they are producing CO2 footprints. Okay, and particularly there was a reporting on the most reputed brand throughout the world, that is Apple. Now, Apple has explained that they are already carbon neutral, and they have made it by 2020, but not globally, in some of the units across the globe. But they have a target, particularly where they are not complying in India. They have declared that they will achieve this carbon neutral by 2030, and also the zero by 2019. So the most important part or the important learning or the lesson that we get from here is basically using clean energy, renewable energy, and also to go for the recycled materials. Okay, recycled and reuse. Basically, this has become a slogan. You know, so people are searching for alternative energy sources, and also people are always looking forward to describing the procedures or developing the procedures rather, so that the waste materials can be recycled and reused for the same purpose. Okay, so that the final level of waste or the final volume of the waste can be reduced. So that is basically the basic background under which this works comes. So our actions for the new uh, uh, era of innovative works should start from this point. So number one is that we should develop a cleaner technology where there is minimum amount of carbon footprints. And then number two is that every procedure has got wastes. Okay, now how to reduce this waste production, because the utilization of waste is going to create a lot of issues for the entire ecology, for the entire planet. So how they can be recycled or they can be processed. In fact, nowadays in our country, there are certain processing industries are coming up who are uh, collecting the waste and then processing these waste materials, and then they are selling as a commercial product. Okay, and I hope a very important such product known to the construction industries, silica fume. Then we can name alkofine. Okay, alkofine is basically the processed product of the fly ash. Okay, and which is very good for developing high strength concrete. Okay, because I have done some work also in that line, and not only that, it increases the mechanical properties of concrete, but also it improves the property of the concrete in other directions as well. So I could take only small part of it, but I suppose that you can also take up the work in that direction, where the recycled materials are being used towards developing the new technology or new construction or the innovative construction materials. Okay. So, with this background and developing towards the eco-friendly material, right? We are searching for certain places where cement can be substituted, or some other components like the fine aggregate or the coarse aggregate. These materials can be also replaced. Okay. So, utilization of waste or the changing the status of the waste from waste to resources, okay, is a very important task that we can take up. So, the various wastes that are available for us, I have already named them. Silica fume is there, alkofine is there, then slag are there. Some of the industrialists are also approaching us for check the chemical composition and check their mechanical strength, check their properties, various other properties, and to recommend them for utilization as a construction materials. Slag, there are different type of slags are there. Okay, so GGBS is one of them. Okay, so whether the other types of slags are also can be used for the construction purpose. I mean, construction, it is in general, it's a very general word. It can be also for building construction, it may be for pavement construction, I mean roadway construction. In many other cases also it can be used. Okay, So the waste materials that we get, that can be used as a cement replacement, or that can be used as a, sorry, replacements, or they can be also used as a supplementary material, so that we can develop the eco-friendly concrete and reduce such things. Okay, so here I have given some of the pictures, although we are familiar with most of them. GGBS, ground granulated blast furnace slag, then there is fly ash, and then rice husk, palm oil clinker, then red mud. This is the oldest material that we use for developing the building materials. Then steel slag. Then these are some of the things which are also people are using nowadays. Ground rubber. Sometimes people are also using. I do not know whether you have heard it or not. In the tire of vehicles, waste tire, there is also some steel fiber inserted. Okay, so once the tires are declared as waste, they cannot be used. So people are also means using those wears, steel wears, which are inserted into the tires, in addition to the rubber which are available for developing the different type of construction materials. So here I have only just given some of the pictures regarding the waste materials. Okay, this is earlier it was for the replacement of the fine aggregates. These are basically for the coarse aggregates. Okay, and nowadays, in fact, this cramped rubber are available as a commercial product, which I was telling, that the recycled product from the waste tires, okay, which is available in the market, which one can use also for specific, of course, not as a generalized construction material, but for specific purpose. Okay, so my list also includes different type of quarry dust, marble wastes, and also the electronic wastes also. Okay. So what particularly our focus is to develop cleaner technology, which will have minimum, okay, in fact sometimes it is nil environmental pollution, and which will help us to towards the sustainability, and eco-friendly, developing eco-friendly products, such as green concrete, okay, which can be developed for of course uh, for a specific purpose. And their strength, mechanical strength, and the other parameters can also be checked compared to the so-called conventional concrete. Okay, so here in the form of a picture, um, I have mentioned that there are natural materials which are collected from the natural resources. Okay, uh, water, cement, and the other admixtures, chemical additives. So everything can be replaced. Okay, or maybe partially replaced, or maybe added additive. So this waste material can be used as a supplementary materials, or maybe used as a additive materials. Okay, so that depends on the situation, that depends on the requirement of the client. So looking at the client, we have to devise the mechanism and check which one is desirable, and which one will provide the final and better outcome. Okay, so that may be for construction waste, demolition waste, or that may be also from other uh, cases also. So recycling is not only that there is only from, it will come from the construction and demolition waste. right? Recycling is a procedure which can be applied in many fields. Like I have seen that in many fields there are waste materials and which are being recycled, and they're made reusable, okay, for making the products in the same direction or maybe in the other direction. I mean that the refractory industry, they have got the waste, they get the waste refractory supplied to the furnace. After certain time they will be thrown out and the new refractories will be replaced. So the old refractory materials which has been thrown away, right, they are being collected by the refractory industry itself, and they process it, and they partly they can use for developing the new refractory products. Similarly, that the rest part of the refractory waste can be also collected by the civil engineering community, where they can process it and they can use it for developing the construction or the building materials. Okay. So with this I close the basic background under which I had a mindset to develop this thing. So here I have we have performed a small experimental investigation, right, to check the suitability of fly ash, which is the largest, waste being produced across the country from various thermal power plants and captive power plants and other industries. Okay, so whether they can be used for developing these refractory products, acid resistant fire bricks. Okay, so that small work we took up, and that was also in collaboration with one of the refractory owner. Uh, so I forgot his name. So that work, that reporting is there. So some of the things I have just the contents included here. So mm, here the introduction, this thing, what I have discussed in detail, they have been just noted point wise, that huge amount of fly ash which is being generated across the country, whether they can be utilized for developing this refractory, because the utilization of fly ash is also a very challenging task for the thermal power plants. Many of the programs that I have attended, that their senior level management, they report that how much percentage they are able to utilize, how much percentage they are not able to utilize, and how it is actually becoming a pain to them, right? So that's why they are also looking forward to utilizing that fly ash, or extending the field of utilization of that fly ash from the conventional one to other one. So this is, you can consider one direction which we were looking forward to, beyond the so-called conventional utilizations. Okay, so under this situation, we have seen that how much fly ash here. Actually, there is a table which explains that the utilization of fly ash, that 50% can be utilized after commissioning. After second year, they should be able to utilize 70%. Similarly, after fourth years, henceforth, they should be able to utilize the entire fly ash. Okay, so that's why there is a pressure on each of the thermal power plants in the country to utilize that fly ash, by 100%. So you will find also nowadays, I do not know, you must be aware that some of the thermal power plants, they have their own fly ash brick manufacturing units, where under which circumstances they are not able to sell it or supply it free to various industries for various purpose. Sometimes they prepare, develop the fly ash bricks, and they also sell in the open market, okay, to comply to the government norms. Okay, and nowadays you have probably seen that in the vicinity of the thermal power plant, everywhere you will find cement plants, because there is a collaboration, or there is a contract between the two, where they develop their plant in the vicinity for the purpose of utilization of the fly ash that they're going to generate. Okay, so this is basically, how much uh, ash is going to be generated. Okay, and how much is uh, being utilized. So there is a table that describes this generation and utilization for a particular financial year 2021. So, however, what we are looking forward to is to utilize the industrial waste, basically the fly ash, okay, for developing a technology, by the so that this can be utilized in the refractory industry. Okay, so there are certain things which we must be very clear. So, what is fabric and what is sustainable fabric? Fabric is basically a block of ceramic material which has got the higher capability for withstanding temperature, heat, okay, and low thermal conductivity. They also sometimes used as the insulating or liner material with higher energy efficiency. Okay, so they can basically they can absorb, the energy because of the elevated temperature. So energy content is very high. Okay, and also, refraction of the heat energy is also very low. Okay, so that the other adjoining structures can be protected. Okay, and by the phrase sustainable fabric, we mean that this fabric, which is blended with or improved with improved with certain other materials over the traditional fabrics, which will have similar, may not be exact similar, but which will have similar, properties and similar applications. Okay. So that is basically the sustainable fabrics. Okay. So the significance, I have already explained with the background, and here there is these things have been written point wise, that the fly ash bricks, they uses basically fly ash extensively, okay, mostly. And another consumption of the fly ash is for the road construction. Probably you have seen for flyovers, okay, for retaining structures. Okay, fly ash are being used extensively, and also a most important part of the fly ash is being used for the by the cement plants. Okay, so and but we have not seen developing fire bricks which is going to be sustainable, uh, and which is being manufactured using replacement of the conventional ingredients of the fire bricks by the fly ash. Okay, normally fire clay, kaolin clay, they are, very costly materials, and I mean they are used in various fields. So it is not that they are available in plenty. They are available, but again their utilization is also manifold. So that's why they are not readily available. They are available, but not readily available. So in that case, if you can protect some of the natural materials and can replace with the fly ash, that was the basic target, so that it can resist higher temperature. Now, higher temperature, we mean what is the level of higher temperature? So in this case, this study was performed up to a temperature of 1350 degrees Celsius and stepwise, not beyond that. Okay, this was the task that we took. So for that, initially, what we did, we tried to compare the properties of the materials, particularly the microstructural and the mineralogical analysis for the kaolin clay and the fire clay, okay, which is extensively used for this thing, for this fire bricks, and that was done using the FESCM. Okay, FESCM means not finite elements, but it is field emission uh, SEM. Okay, scanning electron microscope and XRD data. Okay, so whether they are comparable or not. Okay, and then performing the chemical analysis of all the materials, then checking their physical properties like the density, water absorption, uh, linear changes. Okay, and then comes the mechanical strengths like crushing strength, cold crushing strength, or the compressive strength. Then also the refractoriness using other types of tests. I'll come to that in details. So finally, after developing these bricks, we also investigated the microstructural property by FESCM and other mineralogical properties by using the XRD method. Okay. So here is a very simple table, okay, for different type of mix compositions: F1, F2, F3, F4, F5, F6. So if you see, there are two class of experimental program was set up where there is kaolin clay and fire clay, 25%, 65%. Now, the first case, the fire clay percentage was, if you look at the F1, it is the traditional, more or less, right? Okay. And the other F2, F3, what we have done, we have reduced the content of the fire clay, uh, keeping the kaolin clay constant. Uh, we have added the fly ash. Okay, so 10%, 20%, and 30% we have utilized with uh, the water versus solid ratio as 4%, 5%, and 6%. Okay, so that means as we are increasing the fly ash content, we are also increasing the water content for the dry mixing. Okay. Similarly, in other set, what we have done, uh, we have kept the fire clay, uh, kaolin clay as 35, 35, 35, a little bit on the higher side, and we have reduced the fire clay as 55, 45, and 35 with 10%, 20%, and 30% replacement by the further by the fire clay. Okay, so here the uh, dry mixing has been done using hand, not mechanical mixer, because we have mechanical mixer, but this quantity is very less. So for that instrument, it becomes too small. So that's why we have used simple hand mixing, and then the bricks have been prepared by the hydraulic press in the friction press machine. Okay, so what are the heating systems? The stage one, all the specimens were heated up to 200 degrees Celsius for 4 hours and then remove the initial moisture content. Then in stage two, there are three stages, one, two, three. For every stage, right, the specimen has been, for the first step, right, firing the every set at 950 degrees centigrade. Then for the next, it was 1150 by 200, increasing a further temperature. And the next one has been the 1350, that is the highest temperature. Okay. So stage two is basically, stage one is basically preheating process. That means in stage one, all the samples were preheated so that there is no moisture in the sample. So that is why this is preheating process. If in case there is moisture in the sample, then you know the sample may burst uh, inside the clean. Okay, so and it can damage also the clean. Okay, the furnace. So that's why in stage two, this is basically a burning process, and that is being done at 950 and then further up by 200 at each steps. Okay. So next, this is the entire procedure. So and this has been done uh, uh, the raw materials which has been hand mixed with water, and then by pressing the bricks have been prepared, and then the semi dry bricks, they have been put into fire using the tunnel flame or the furnace. So this firing has been done. This can be done in muffle furnace, but here we have done this in the refractory industry itself, so that the people who are manufacturing the regular fabrics without using the fly ash, they can see the changes, and they can also, certain experimental setup is also required, which we the civil engineers do not have in regular courses. For the test also, we have fired those samples in the tunnel flame. Okay, so these are the samples after in the heating stage. Okay, burning stage. So this is the color of the sample at 950 degrees Celsius. Then the second part, second stage, this is the color of the sample at 1150 degrees Celsius, and at 1350 it was the most dark samples. Okay, beyond that we could not do it, right? Because after that we didn't find the strength which is being retained in the samples are significant. So that's why we could only prepare the sample sets which were fired up to 1350 degree Celsius. So these are the expressions. These are familiar to you, I suppose, that bulk density of the samples, then apparent porosity. This is basically the porosity which talks about the the capacity to absorb water at the surface level. Okay, so you have seen probably that when there is a clay brick and we drop water on the clay brick, what happens? Initially, the brick absorbs the water, but the water remains on the surface. It doesn't penetrate into the inside of the brick. Okay, and it actually it is being absorbed in the pores present in the surface. Then water absorption, in fact, that reflects the uh, the the entire set, how it is being prepared. Then the permanent linear change, which is a very important parameter which is required for the refractory products. So we tested the results in the XRD and as well as the FEACM. So here this is the kaolin clay, and here this is the fire clay, which are being regular use in for preparing uh, the refractories. And these are basically part of the material characterization, and which is being done by the metallurgist, people from the material science background. Okay, we use the data, the metals present, and what is the intensity of the metals present, that we can understand from here, and they run the analysis and supply the data with the exact value of the percentage, which I have tabulated, are being shown in the table. Okay, the chemical composition in terms of the different oxides: aluminum, calcium, iron, potassium, okay, titanium, and other things. Okay, so if you check the chemical composition of the material, okay, which you have received from the after the test, so fire clay, fly ash, and kaolin, fire clay and kaolin, they are almost similar, and we have found fly ash. Is very similar to in other properties. If you check other ranges, they are almost close to the fire clay. Okay, but some of the things are not, of course, balanced. Okay, so like you see, if you look at the fly ash, it has got the iron oxides on higher side. Okay, so naturally, this indicates that this magnetic separation is very essential whenever we are going to use the fly ash for developing the refractory bricks. Okay, that is one important thing that we can see very clearly. and the other components are more or less in parallel. So looking at this composition, apparently it seems to be that uh, obvious reason is there that we can use this for developing the refractory product. Okay. So here the property that we have measured, okay, and that we have got, they have been shown in the form of the histograms. So this is for three different temperature sets: 950, 1150, and 1350. And for the six mix, F1, F2, F3, F4, F5, F6. Okay. So what we observe is basically that at 950 degrees centigrade, the bulk density is going to get reduced. So like from F1 to F3, from F4 to F6, there is a reduction in the value. Whereas in higher temperature, if you look at 1350, all the values are very close to each other, very close to each other. Okay, so that means there is a word called sintering. Okay, I suppose you are familiar with this word, sintering. This word is basically very familiar in the steel industry. Uh, while the various ores which are being processed, melted, okay, after that the refined steel is being taken to the sinter plant, okay, for sintering means basically when the loose particles they get amalgamated together. That means there is a solidification. Okay, so that procedure is known as the sintering. So probably at this temperature, the sintering has taken place so nicely for the fabrics that we have got a very good comparable values of the bark densities, right? So, but which is not clear, although the variation percentage is very less, but from the histogram we can see that there is a variation. That means bulk density is going to get reduced with the higher percentage of the fly ash present in the fire bricks. Okay. Then the apparent porosity, what we have seen, apparent porosity has reduced. That means obviously the material is going to be more porous, okay, particularly at the surface level, and that has been checked with different temperatures: 950 degree Celsius, 1150 degree, and 1350 degree. Okay, and according to the IS code, IS 6 and IS 8. Okay, since this work, I do not know. Nowadays, the IS codes have been categorized as CED, under CED category. So this code, I do not know, because this work has been done 2 3 years back. There may be a change, or there may be an update in this regard of the IS code, but they have been checked with respect to the IS code regarding the porosity values. Okay, for the fire clay bricks. So here. If you look at the final conclusion in this regard for the apparent porosity, that the fly ash enhances the sintering and also increases the micropores, which might be the reason for higher porosity, and particularly which is not desirable for the mix with 30% fly ash replacement. So at the other, I mean, up to 10% replacement, up to 20% replacement of fly ash, the results are more or less comparable. Whereas for the 30% replacement of fly ash, right? If you look at the results, we find that because of the sintering procedure, okay, the porosity level has increased, okay, and may not be acceptable. So we look at the water absorption. So eventually the reflection of that porosity is there in terms of the water absorption as well. So for the higher replacement of the fly ash with the fire clay, we find that the water absorption also increases. Okay. So that has been observed, and that has also been compared with IS 3495. Okay. So all the compositions meets the limit, of course, uh, of the firing temperature at 1150 and 1350 degree Celsius. Okay. So then we checked for linear shrinkage. Okay. So if we look at the figure 7, there is some shrinkage percentage has been reflected. Okay. So if we look at the figures, uh, that F1, F4 achieve almost similar 1.76% and 1.6% respectively, whereas F4 and F6, okay, they have got a very dark reddish color, at 1350 degrees Celsius, and due to maybe that may be considered as the overburnt due to high percentage of the fly ash. Okay. So the shrinkage, linear shrinkage from F1 to F6 at 1350 degrees Celsius was found to be the maximum, almost 5.6.5% for the F6, where the highest percentage of fly ash replacement. Okay. This is regarding the crushing strength, cold crushing strength. Here we have found that the strength, of course, has improved with the higher content of the uh, fly ash. Mm, there is a sharp increase that has been reported, that we have found. Okay. Uh, of course, since only a few set of samples have been tested, maybe it may require some kind of validation, because this is a work in a new direction which has not been reported so far. Normally, in the journals, you will find reports where you have got a positive result, but I think that when there is a negative result, that should also be reflected, because that is also essential for the researchers to know that this is the direction in which works have been performed. Number one. Number two, the reports are not found to be encouraging. That is also necessary. So that's why I always say that whenever we go for some kind of new directions which are not being reported in the literature so much. Okay, so in that case, in case there is a negative reporting, we should not feel, anxious. Rather, we should include them in the work, in the report, so that the future researchers, they also find some kind of, positive directions they are able to find out. Okay. So here, some, of course, till now we have got, except the porosity, we have got encouraging results. So here, the conclusion that we find, the that the temperature which is 950, that may not be adequate for the sintering of the refractory material, but at 1350, obviously, right, even in 1150 also, it shows a good improvement in the value of the cold crushing strength of the refractory products. This is RUL and PCE. uh, mm, uh, this is some kind of cone test is there. I cannot explain. I didn't include them here probably. Uh, this RUL means refractory, some, I forgot the name. These tests are basically to justify the refractoriness and the kind of, the um, PCE test basically indicates the temperature in which PCE means pyrometric cone uh, examination, I think, cone test basically, where there is a triangular pyramid type samples are being prepared with specific dimensions, and they are subjected to elevated temperature as per the code IS 1528. Okay, and they basically reflects that how it is going to bend, right? So the cone remains vertical and they are being placed in the furnace, and upon increasing the temperature, how much they bend uh, uh, at different level of temperature. So that is to check the stiffness, stiffening property when they are going to be unstiffened as a refractory material at at what temperature. For that test we perform pyrometric cone test. Okay, and this is refractoriness means, for a refractory material there is a change of phase of the raw materials from at the refractory level. Okay, so at what till what temperature it can perform that or it can retain that refractory character of the material. So for that REL test is performed. So these two tests were performed not in our laboratory but in the refractory industry itself, and uh, they are not satisfactory. But if you look at the curve, uh, if you see the curve, nature of the curves, we see tests, of course, they are not satisfactory. At RUL, somehow it meets some results, permissible values. Okay, uh, means it is not very encouraging performance that we have got, particularly for this in regard to the refractory justification of the refractoriness under the load. This is basically this RUL test. RUL test is basically like, say for example, I can explain in this way. Say for a mechanical test, what we do, there is an ambient temperature in the laboratory, and we have a, say, simply simple that compression testing machine. Okay, so we are breaking the specimen at ambient temperature. Now if the sample is kept inside a furnace where temperature is being the sample is being elevated to a certain temperature, and at that temperature uh, there is mechanical loading. So temperature is also increased and mechanical load is also increased. That means it is thermally loaded and mechanically loaded. So both the loadings are being done, and after that, what is the value of the temperature in which the sample is going to fail? That value is we receive from the REL test. Okay, so that is basically that reflects that the strength of the property under the sustained loading at elevated temperature. Normally, what we do, we place the samples at a particular temperature, and then we bring it after the temperature, we cool it down, and then we go for the mechanical testing. Okay, so this kind of testing is not applicable for the refractory materials or the refractory products. So for them, we need to go for this kind of test where both the thermal loading and the mechanical loading is being performed. That is related to this REL test. Okay, so these there are certain certain SEM pictures are there, scanning electron microscope images are there for the different mixes that we were performing, F1, F2, F3. So for different level of replacements, and we were just observing the different the with the same scale, right? What is the value of the pores, or how many pores are developing, and these are the things that we can identify from this microstructural images. Okay, these are the XRD patterns which reflects the material present minerals present in the combination. I'll not go into the details of it. I hope those who will be working in the material fields, particularly, they have to know how to read this figure and how to analyze this figure and to bring out the interpretation of the results from the XRD patterns for various materials. Okay, so with this, I have just a few conclusions regarding this. So number one is that from the XRF analysis, okay, X-ray analysis, which we have done for the materials, fly ash, fire clay, kaolin clay, right? They are more or less, they have more or less similar type of composition. Hmm. And but only thing which I have mentioned that the iron content in fly ash is a little bit on the higher side, which is not desirable for developing the refractory products. So, if we would like to use fly ash for the purpose, there is, we have also seen that the results are good, maybe acceptable up to 20% replacement, of course, with the temperature 1350. That also, that is very important. Up to this temperature, up to 20% replacement, the results are encouraging and maybe acceptable. Okay. Uh, so provided we can remove this iron oxides uh, from the fly ash through different, separator, okay, mechanical separator. And we have also seen that the porosity level was a little bit higher. So from the PSM images, we have confirmed that porosity level and the size of the pores with the increased percentage of the fly ash. And another thing which is important that we have noticed, that although there are pores, the pores are not interconnected. This is a very important property of a material, because, say for example, there is a chemical plant, okay, and there is a concrete construction, and it is continuously exposed to different type of gases and vapors. Now, within the concrete, depending on the type of grade of concrete, right, the porosity, the permeability of the concrete will be, can be justified, can be measured. But what is important in that case, that say for example there is an enclosed chamber inside concrete, made of concrete, and where there is gaseous materials, it is used for storing the materials. Now, in case the pores are interconnected, right, that particular concrete is not sustainable under that chemical exposure. That is very important. So that's why we need to know, we need to go for this microstructural study by which we can understand whether the material can perform the specific purpose or not. Okay, so it is not that always I mix it, I add this or I supplement this, then we can have a different type of products which can utilize the the waste materials. That is fine, that is one angle from which we can think, but at the same time we have to also ensure that the purpose for which the material is being developed can be served. Okay, so in case it fails, then in that case, of course, we have to think otherwise, so that how the performance of the product can be improved. So here XRD peaks for the mulites that we have seen, that has got an increasing order, and the quartzite peaks decreases with the higher fly ash, whereas the mullite peaks increases. Hence, in this case, what we have seen, that the addition of fly ash uh, improves the microstructure or mineralogical phase a little bit. Okay, so we have just tried to understand that by doing the entire study, we took a lot of time to interact with the industry people, to get the materials, raw materials, and to prepare, to study the literatures and all these things. We have found that it may be possible to use the bricks for the experimented batches to supporting structures in the steel iron making industry, where supporting structures are not directly exposed to fire, but they are lined with expensive refractory bricks. So the conclusion is that the performance of the fire resistant brick is not so good, which can be used for the furnaces, but it can be used for some structures which are not directly in contact with the fire but exposed to high temperatures. So for them, these bricks can be used as a liner material. Okay, so this is one observation that we can make. And the results of the present investigation that accepts the technical suitability of the fire fly ash as a partial substitution of the fire clay. Based on the outcomes of this investigation, uh, it is recommendable we use fly ash as a partial mixture for the manufacturing the clay bricks for the secondary refractory uses. This is another important point, that all the refractory products are not exposed to elevated temperature directly. So there are also refractory products which are being used as a secondary refractory uses. So for them also, this kind of refractory product can be used. But industry will normally uses the develops the products or manufactures the products which are being regular in the regularly used. Okay, so they will, in case there is a specific customized requirement for a particular industry, then they can go for this kind of uh, specific products which we have for which we have done the experimental investigation. Okay, so these are the codes that I have used for the purpose, and some of the references. Of course, it is not all, but a few references I have included here. Okay, and so now uh, I'm open for the question and answer. Just a brief summary, that's what I have tried to expose myself is that what are the current challenges in the global market for the for the civil engineers. Okay, as a civil engineer, normally we look forward to civil engineering products, building materials. But in this case, I have shifted my focus, not directly from civil engineering, but a little bit away from it, where there is a different industry, refractory industry, and for them, whether the waste material can help to develop a clean technology. Okay, towards also reducing the carbon footprints, where the fly ash can be not only utilized but can be also utilized for a specific or customized purpose. Okay, thank you very much. I think this much I wanted to share with all of you. This is one of the directions in which I have done some little work. I have also worked in other directions. Maybe I can share in other platform whenever I'll be finding some opportunity to share with you, so that we can also collaborate or we can work together. Thank you very much. Uh,
Thank you, sir. Thank you for your very informative and detailed presentation. Sir, you have very well touched upon the global issues related to the conservation and need of protecting the environment and setting the clear background for why the refractory industry is needed and why it is there. So you have clearly explained us the detailed manufacturing process and informed about the details of industry status and industry issues. You have also clearly given us and shown the data in terms of data how it is so important, and it contributes to the larger goal of clean sweep and carbon neutral 2030 and carbon zero 2050 has been very clearly explained, sir. Also, the difference between the fire break and sustainable fire break, all these terms and terminologies, I am sure that all the participants have got a very clear idea and a very clear glimpse of every idea of this. Also, the chemical composition, especially the need of the microstructural study. As a civil engineer, why is it important to understand the material, how to serve? The importance has been very clearly pointed out by you, sir. So we are very thankful for that, and I am sure that all of us who have participated have got a clear glimpse. sir. Now with that, I pass on to Dr. Arthri Bondopadhyay for the question and answer round.
Okay, thank you. Thank you, Dr. Rajbunshi.
Thank you, Shomi, and thank you, sir, for your wonderful presentation. Now, I would like to invite any in-house faculties and participants for your question or any queries if you have on this topic.
Atre, can I participate?
Sure, sir. You don't need to ask, sir. You are most welcome.
First of all, I am extremely happy. Professor Samanto has given a wide range of products, its advantage, disadvantage. Many people are only discussing advantages, but he has also thrown light on disadvantages, and also he has given the scientific interpretations behind that, as well as you know what we can do in future. That is also very important because the material science is a subject where I don't think there is any limit. Sky is the limit. You can go on developing many things in many way in different parts of the world. It is not that in India it's not possible, in the US it is possible. I don't think so, except the sophisticated some tests which the in US or in Britain or in Australia they are performing. The the basic understanding of the material behavior and the chemistry part of it, physics part of it, or even I tell you the computational mechanics part of it. Indians are very strong. That what I have observed abroad and here also. But that's why I once again want to thank Professor Samanto because what I have noticed, because I could not attend the initial part of it, but remaining the most of the part means 95% I have attended, uh, and frankly speaking, if you listen to this lecture again and again, I'm saying again and again, and then you will find that your eye will open like anything. You will start thinking because you have got the basic knowledge of physics, chemistry, everything. You have everything. Our Indians are very good in school level and also in basic level, but only thing they don't open the eye sometime. So this is just an eye opener. Consider it's an eye opener and accordingly listen to this repeatedly. And it is in the YouTube. It will be you can listen even after 1 year. Now, um, uh, I just want to discuss few things with Professor Samunto. Uh, that is, you know, you were talking about sintering, and the sintering when we you know perform some test means on alkali activated fly ash composites. There we found that the sintering it is occurring at a temperature of 800 to 900 centigrade, and that how we could identify that because just in that range we found that uh, the composite strength is suddenly rising, but it is not that at 1100 1200 again it is rising. No, again it is declining because with temperature obviously there will be damage, and so this sintering is a very important, very important, and metallurgists they are using for a long time. We are new in this field. Now this sintering, the way you explained, side by side, if you look at the peaks, that means whatever the peaks you got in XRD at lower temperature and at the temperature where you have observed sintering, then you will find definitely a new product has formed, and that new product is generally quartz, generally, not always, and that gives you a bit of higher strength. But the moment you are going beyond that, then uh, again, normal damage process continues, and you won't get the advantage of that. So we can say that this is the optimal one. Now, what is my just you know interest is that I want to know from you that is it possible to do all these tests, under alkali activation, and we can avoid many things because we found that in under alkali activation, uh, many problems can be avoided. And I'll come to that because if actually allows me, then I'll come to you one after another. Maybe
Sure.
13, 14 points are there. So I have written down. And this is, the wonderful platform where I got an opportunity to discuss with a really good researcher with a very scientific background. So I don't know whether actually will allow me or not. So that's why I say that. Do you think that alkali activation uh, will give you better material?
Sir, actually, alkali activation also takes place at a particular temperature, and it is, I think, not the normal one. It is at higher elevated temperature. So, since I do not have much exposure and experience in the field, but only once, I suppose, one of my undergraduate student attempted to do a little bit of it, but I didn't explore much. My idea is that similar things can be performed, can be checked as well. Can be checked
Uh,
as well.
you see, we all know that the silica aluminum ratio is increased. Hence, we are expecting higher strength. Now you know that in fly ash there is plenty silica but less alumina. Now the silica alumina ratio maybe say 4 in a good fly ash, but metallurgists in their their metal developing, they are claiming they have went up to 35.
Acha.
They are
30.
claiming. Of course, it is 35 silica aluminum ratio. And
Okay.
it is amazing, but it is possible in metal because the way the fly ash is dissolved in alkali, and after that, whatever reaction alkali, due to whatever reaction is taking place, yes, probably, whatever you have done, probably that is the highest one. Of course, you can add amorphous silica from outside to increase the silica, and silica aluminum ratio will increase. That is fine. But what is, my, you know, way of thinking that, if you add more silica, more alkali, that means you are adding alkali from outside. And those particles, which are pozzolanic in nature, they will get dissolved. And the moment they are getting dissolved, and then again they are rearranging the molecules, automatically the crystallization slowly forms, and that is the gelation stage, and then it will get hardened, and we will get higher product. I mean, high strength product. That is what is there in alkali activation. That means you have to add alkali from outside. Similarly, you can add amorphous silica from outside. Maybe the cost of alkali is there. If you use silica, you can go for in the form of silica fumes. That is also not much costly. So this is an area I think that if you give some time and do some kind of research, and what I expect that the people like you, if you collaborate with us, will be very happy. And uh,
Sir,
second thing,
it will be a pleasure to explore more and more. The thing is that the we have the orientation, research orientation. The issue is with research orientation. The more we have the research orientation and the facilities that is required, that is very important, because nowadays I'm finding some difficulty in regard to the facilities. Means we have some facilities, but this kind of work in material science requires many more facilities.
that is, you are 100% correct. For that, we need another friend, CSIR. Maybe.
Yes, yes.
So,
Test house, test house will be
just
there.
stuff. Another thing I must tell you that, if increase the fineness of fly ash, that is in different way you can do it. You can put the fly ash in the ball mill, a small ball mill in the laboratory, and if you rotate that for a long time, slowly it will, the fineness will come down. And something we have done, that normally the fineness is more than 90 micron, even more. And if you can reduce it to 40 micron, that means the fineness level, then the reactivity increases like anything. And if the reactivity increases, then what is happening, that the entire material is participating in the dissolution process. So as a result, you will come out with magic materials. So that is what I wanted to tell you. Another thing you told about rubber.
Cramped
Yes,
rubber.
rubber. And this in Europe and other places they are doing it, because actually what they are doing means they are doing something new, and they are showing that we have produced. But it doesn't mean that they are using in the industry. It is
No,
sometimes showcase research.
means, sir, there are many things called structural concrete, like pavement quality concrete. So, if they can clearly explain that what are the area of application, if they can specify, I think in that case they can attract. Instead of doing so, nowadays I have seen even earlier also, like when there is a good work reported in the good journals, they have performed a very little experiment. Like we normally perform
True.
huge number of experiments,
Yes.
but the other things, means how they have planned, how they have arrived at that particular small plan, that is very significant. And also the outcome, what they bring about, uh, that is also interpretation of that is also very scientific. In
Yes.
most cases, in our cases, we just, means, we report only the results that we get. We do not report the derivative of the results. They
Yes.
report more derivative of the results than the results, direct results that they get in the laboratory.
Yeah.
So
Actually, what you know that uh, my way of thinking about rubber, that if you can make it, in the granular form,
mhm, mhm,
and after that means slightly bigger than sand.
mhm, mhm,
And after that, if you try to make concrete, that
mhm,
alkali activation, whatever it is, whatever
mhm,
the best way,
mhm.
except cement, because I don't like cement because of this, it will spoil everything in future. Because limestone is not available, especially in our country, and so that's why all those rubbers in granular form, together with other materials, if we can develop a ductile concrete,
Mhm,
probably it is possible.
mhm.
Probably it is possible, because I have not really checked. I am just transferring to you, because you can do many
I
things.
have not yet used rubber as such as a means ingredient for developing any product. I have not used, but my some of my colleagues have worked a little bit. I do not know what is the reporting, but they have done. But wonderful thing that I have noticed from a journal, good journal, that in one paper they have used. We talk about fiber reinforced concrete. They have used the fiber out of the waste tire.
Yeah, yeah, that is they
That
are
is
doing.
that I have found very
No,
interesting.
that they have done, but now people are talking about plastic pavement, plastic roads. So maybe I don't know whether they are indicating ductility or not. Obviously, ductility is one of the aspects. Otherwise, why you are putting reinforcement? We can only put concrete.
Mhm.
So another thing is, because time is short, that's why I'm skipping to this. Another thing I have really learned from you, that the stiffness test that we have never tried. That is very important because strength and stiffness, obviously they are related, right?
Mhm.
So I will try to do much more stiffness test in my laboratory. And I think regarding the pores, whatever you have mentioned, right? I think if you just go for 2, 3 samples MIP, then it will give you the entire spectrum, the total pore volume, uh, and the maximum diameter of the pore. It takes about 5,000 rupees, or maybe for education institute CSR may take 2,000 rupees. But you can go for MIP, mercury intrusion porosimetry, that you can do it. I think that will give it. Another thing which you said, that is, uh, the pores are not interconnected. You see, if the pores are not interconnected, that is also bad. If the pores are extremely connected, that is also bad. The reason you have explained, if the ports are connected, what will happen? Aggressive agents will come in, so that is fine. Again, if the pore is not really connected, then what is happening? Many research, this vapor pressure means the when it is temperature is increasing, the vapor pressure develops within the pore, and that creates a tremendous pressure, which happened to the ureteral, and ultimately concrete will burst. So, interconnectivity, the moisture movement path, it should be there, and there is various way you can control the moisture movement path. But only thing, it should be optimal. It should not disturb us in with respect to strength. It should not disturb us in respect to vapor pressure. That means there is some optimal. So
So
that is very clear.
it may be based on specific area of application.
Yeah, yeah, yeah,
Means everything means particular category is beneficial for a particular application.
yeah, yeah. No
Another
doubt.
thing is application for another area.
Yeah.
So specifically for those category of developments, maybe the customization is required.
Yes. No, your particular case, 12% you got the porosity. Uh, but even one can bring down to 5%. And if you reduce the, this porosity, means actually pores are reduced. And then pores are reduced means interconnectivity is another problem. So, using some kind of admixture, if we can, keep the water cement ratio at the lower level, and that way, if we can manage to, reduce the water content, uh, you know, uh, which is excess to the hydration, that means then that is the best one. But best one means that again the interconnectivity. If it is interconnectivity is vanished, then again problem is there. Moisture movement distance are required. So can we keep it, some kind of optimal solution? Can we make some?
Sir,
That
that's
is very deep.
you are absolutely it's a very important point, significant point rather, has been mentioned by you. I think if we are working in the direction of concrete or concrete like materials, these issues will play a key role in developing the properties, different aspects. But since in this case, particularly for this refractory, I think the means here strength is not important. Only thing what we look forward to, whether it can have enough durability, and whether it can perform the desired requirements, fulfill the purpose at that particular range of temperature. Sir,
Yes.
we cannot go,
No,
we
no.
only up to 1350 degrees Celsius.
Maybe beyond that.
Uh, Beyond that, we didn't try. We have means it was not a complete one. It's a, just we started with a the entrepreneurs who have the refractory industry. They also they were also in line with us, but they also helped us to check this at the laboratory scale. They did it not to that perfect means with that number of microstructure study and all these things. They did just for
Ah,
the fun.
yes.
So I mean,
Conventional mix
yeah,
design.
we just added some scientific value to it to justify its stand, our stand, for a particular restricted within that temperature only.
Acha, I've got a question in mind that definitely they talk about the life.
Mhm.
And if they talk about life, what is the normal life of that particular refractory material? 5 years, 10 years, 25 years?
No, means refractory materials is a regular requirement of the steel industry. Regular means I do not know after how many cycles actually.
How many
They
cycles?
cycles they have to replace that refractory material and throw away, and the fresh refractory material has to be used. That is the thing. That is why there is a regular requirement of the refractory
That
material.
is true, but here durability
Mm-hmm.
means if I connect durability with life,
Mm-hmm.
then
Mm-hmm.
in that case temperature is the main
One,
culprit.
one, one issue is temperature, and one issue is how many
The gas.
cycles the material can perform.
No, and also the gas developed within the furnace means that may also affect the material. Yes or no? But what I mean to say that uh, how long they use a particular lining means
How much time? I think time is time they measure in terms of the cycles. Means
that is
that is very that is the issue there. But they test that refractoriness. Are you well?
acha,
Refractoriness.
depending on that,
Refractoriness. Are you
and
well?
that is
That is the.
at least 5 years.
I don't think 5 years. I don't think it is not that much.
No, why I tell you because the moment you will give a proposal,
Uh,
then obviously, if you give a proposal of higher cost,
mhm.
suppose, then obviously the effectiveness is will come into the picture.
Mhm.
Again, the life will come into the picture, and then the entire life cycle, all these things, these questions will come up. So that's why I'm asking that. That should be related to
I
life
mean,
also.
I do not know. At Haldia, there is some refractory industries there. Is there any refractory industry?
Yes, it is there. It is
It is
there.
there. It is there.
But I've never asked them because uh, uh, we are not that,
No, actually, I got this
we are
opportunity.
trying to do something only.
I got this opportunity while I was a member of that design clinic. Actually, that project of MSME Government of India. So for that entire reporting, I visited them, their plants, collected data and all these things. That is how I got the interest actually what they are doing, how they are doing, and what they're developing. But the performance of the refractories, I mean by the end users, by the steel industry or by the other industry, that I didn't know actually
No,
how they.
actually, I tell you, this is the thing we are trying. But only thing is that money is a factor
Mhm.
because wherever you go, you need at least a cycle or something. So, and you have to spend there 3, 4 hours. So, money is always required, even to repair the cycle. So, the question comes that the at least I have visited not much, out of 40, maybe 10. And they are showing tremendous interest. But when we come in terms of, some kind of understanding where money involves, then they are thinking, yes, you have to place it before the board and all. Like that they're doing. Anyway,
Right.
still I tell you that I'm not naming the companies, very big companies. We have started working on with them.
Actually, sir, that they are like industrial research and academic research. Two things are different.
Different.
Industrial research is basically profit-oriented development.
Yeah, yeah.
Only looking forward to profit-oriented department. Like, but in academic research, we do not do such things. We, of course, if it is so, definitely there will be some good things, but it is not always that.
Yes, that is true. In our department, we have got 20 faculties around, and almost all the faculties, they are involved in research, and research means they are contributing papers regularly. But still, then I tell you that in many situations we are collaborating, because money is always the factor. You see, if you have do some microstructural test, then you have to make CSR as your one of the friends.
Otherwise, it will be
Other,
very difficult.
or you have to go to Jadavpur and say that 40% reduction of like that 60% we are like that. So things are moving in right direction. That's fine, but at the same time, industry also, if they want to do something, uh, they should invest something. Of course, I found one or two companies, they have shown interest, and
The industry
they may give us few
is
lakhs.
participating. Means earlier it was nil almost. Nowadays they are participating in developments like here I can see some small work, of course, but again they are not willing to give much time. But we are not sitting only for that work. We have also other
No, no, no,
assignments.
no. See, you have already mentioned 12%. This is the highest, that particular
Mhm.
percentage, and there are so many power plants are there. And you also mentioned about the regulations, that even you want to make brick, you have to use fly ash. If your fly ash is within, if your power plant is within 50 kilometers of the sub particular site, even then in Odisha it is implemented. Even then, these industries, the fly ash, whatever, many companies are there. If they spend 5 lakhs of rupees, nothing, it's a peanut for them. But even then, uh, they are thinking at least 20 times. After that, say, we are sorry, at this present moment, we don't
I
have much
means in
money.
our country, sir, since you are strongly connected to the industry, and I know that you are doing lot, trying to do lot of things. You have done and you are still trying. But in our country, people who are working in that industry, they have a absolutely different mindset.
Yes, that is the problem. That is the
Means
problem.
that is why means if they come closer, like if they are they are like in our case, we are judged by number of publications, we are judged by
Yeah,
number.
yeah, that's the
Similarly
problem.
for them also, like contribution to industrial research, they have to perform, and that should be one indicator for their upward movement or whatever it is. This kind of things, I think, until and unless it is there, they will not come closer to that. Means in foreign countries, most of the people are working in the industry and they are in touch with the academics and they are writing papers. Many of the papers are means work and paper are jointly done by the people from industry and academics, but which is hardly visible in our country.
But I can share one example. In US, there is a transport department. They are connecting industry and they are connecting academicians. And from there,
Okay, that's a
they are,
society. That's
they are just connecting industry and academicians,
basically
and
society.
a consortium type. And uh, some part of it, is going to NSF, National Science Foundation of US, and from there also you can get some. Of course, success rate is very low, but you can try. So, transport department is playing a very major role because it includes your
They're trying to
material,
connect people, connect
yes,
people.
material, bridges, many things they have included in transport department. But in our country, there are many transport departments, surface transport, road transport, this, that, but nobody bothers what we are interested or what we can contribute.
And
Another thing, just I will finish within 2 minutes. Three, please allow me 2 minutes. Um, that is, do you think that uneven firing is a major problem? Because when you are putting the brick in the kiln, I found that many times that the color you have shown from there, it is coming to my mind that is it due to uneven firing
yes, it may be, it may be, it may be.
and this reduction of strength with temperature, right? How much it has reduced means percentage wise means
Strength reductions are for this case we have not found. In fact, they are almost parallel. Strength reduction almost nil,
nil.
almost nil.
No, I am talking about if you compare the strength at 1350 and if you compare the strength at 950, right? How much strength has difference in
Strength
strength?
reduction till that point, strength reduction we have not noticed till 1350-degree temperature.
Then do you think that the number of cycles will come down later on?
Uh,
Maybe because something will happen because
Yeah, definitely, definitely, sir. Means actually, we don't have furnace for that higher temperature. We are trying to have, but till now we don't have that facility. And for the industry people, they will not operate for a clean for like testing say 20 samples like this. So we could not make it actually beyond the temperature. If it can be tested beyond the temperature, then actually range after which they will not be able to perform can be clear.
yeah.
Uh,
I don't have any question at this moment, but only thing I have got an appeal to all the participants and through this YouTube, those who are watching this or they may watch later on also that HIT is, to my opinion, is an excellent institute. There is a very good academic environment, and especially in civil engineering department. Though I am new, still I found that the faculty members are extremely actively involved in research. They are helping like anything. Whenever I am requesting them for anything, they do it, and they are do it by their own also. Under the circumstances, how long I'll be there in this world, I don't know. But what I want that this particular department, especially civil engineering department of HIT, it should, you know, contribute to a particular level so that they can put a mark on this earth. And this is definitely will happen within 5 years. Only thing is that we need help from people like you, people like from CSR, IITs, because they have facilities. Only sometime, for a particular instrument, we can always jointly work, and money is sometimes is a factor. Because without money, you cannot do MIP, you cannot do XRD. We have XRD facility, we have many things, but MIP again we have to go to Jamshedpur and Jadavpur University, so or IIT. So that is my appeal to everybody. who are watching in this YouTube or maybe watching later on, that please extend your hand to HIT Civil Engineering Department so that you know I may not be in this world, but my younger generation will make a mark on this art that they have
So
contributed to great
absolutely,
extent.
I do agree with you. In fact, the fresh blood that
Yes,
has joined the department. I see Shomi is there also. So and also I think new faculty like Dr. Payal is also there. I have seen
many, Deepti, then
Deepti is
your
also Deepti. I have met
Amit,
personally.
Devanjan,
Hmm.
then Kaushik, Ajit,
Hmm.
many,
I
and
have not.
Bijoli at it,
Yeah, Vijay is
always
also
with
there.
us,
Hmm.
Soikot Shrom,
Many young bloods are
all
there.
20.
The only thing is that I was telling yesterday to one of my student who is pursuing now some research work. So yesterday was his birthday, and he
Okay,
came to meet me,
okay.
meet me. So I told that the only thing in life to learn is how you are meeting the opposition. If you can handle meeting the opposition in your life correctly with the correct perspective, I'm sure that nobody will be able to stop you. And
Thank
that
you
is
very
the only
much.
thing.
Thank
Thank you,
you.
sir. Thank you very much. Thank you so much, sir. And I wish all the best to my colleagues of HIT Civil Engineering. Thank you so much, sir.
Thank you.
Thank you, Atri.
Atri, your sound is not coming.
Yes, sir. Thank you, sir. Thank you, Professor Hose, also for your encouraging words. And Samantha, sir, always as thank you for your wonderful presentation and wonderful informative session. I personally have one question, that is there any optimum temperature to which fly ash can be used as the lining material? Means after which temperature it will be not be effective. Is there any limit to that temperature right now?
Mm, right. I don't know yet that any liner material which is going to be developed using fly ash is operative right now. This is a kind of idea we had in our mind that why not fly ash for this purpose. And we have seen this active till 1350. This much I can tell only. I cannot tell that it can, like say, flue temperature for chimney liner material. We use fire bricks, but the temperature is quite high. It is not only this much, and it is also variable. It is not a fixed. So some more investigations are required to draw conclusion. Conclusion cannot be drawn based on a single work. And I cannot conclude, say, for example, many a times it happens that we make conclusions, a half dozen conclusion based on a small work. It is not good.
No, but one thing you have mentioned
Yes,
that the temperature of the flue gas,
yes,
obviously up to that no problem.
yes, up
And
to that.
after that, if we can use fly ash
Mm-hmm.
combined with others under
Yes.
alkali activation, if you
Mm-hmm.
can combine together,
Mm-hmm.
then the strength of a particular person increases when many other hands are coming, joining to
Yes,
him.
yes, yes.
So this is what we have to do.
Yeah, 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 definitely, definitely. If means the angle from which we are actually thinking about the product or about the utilization, about the application. So if we can sit together and work together in a particular direction, one by one, gradually, definitely we can arrive
Yeah,
at
yeah,
a
yeah.
conclusion. Arrive at a conclusion.
Sir, one more, last one. Sir, is there any application of GGBS in place of fly ash for this kind of sustainable fabric?
Mm, for fire brick means whenever we talk about fire bricks, I suppose we must explore more about the refractory properties.
Properties, yeah.
But usually we have seen GGBS for concrete, that we have seen for normal purpose we can use. But for elevated temperature also we have used to some extent, but not again, not beyond the 1000-degree temperature. Up to 1000 we have seen.
No, you see this GGBS. It is providing you CSH gel. CSH gel is not that good in high temperature. But the moment you are coming to fly ash and also alkali activation, it is giving you aluminum silicate gel. Aluminum silicate gel is, it can withstand very high temperature. So GGBS, I don't think, because he has used metacolin.
Yes.
That is the reason. And fly ash, that is the reason. Why
Yes.
he has not chosen slag.
Thank you,
Slag,
sir.
sir. Another thing is like for slag, particularly, I think for any ceramic refractory, these are some other directions.
Yeah, yeah,
Construction field materials, they're different. Like I was talking about secondary temperature exposure.
yeah.
Like primary temperature exposure may not be it is useful. For secondary, maybe it can be useful.
It
Like
can.
it can reduce also the maintenance cost of the industry because they
Yeah,
spend a lot of money for maintenance for replacing the concrete.
yeah,
So
yeah.
in that case, it may help.
Yes. But fly ash is, excellent. You can use it, transform it to a great extent.
Yes, yes. It is being used already. It is in use.
Already,
All
already.
it is in use.
Any other, Atri, if anybody wants to ask any question, you can
No, sir.
request.
Comment section is filled with thanks
No,
and
no.
regards.
Our faculty members,
Our
if they,
faculty, sir. If anyone have any query, please they can ask now.
I think Deepti, you have got a question, is it not? Because you are working on temperature,
Yes, sir.
ductility, and all these things. Or maybe you have seen something in temperature,
Yes, sir.
softivity, many things you have observed because he is working on high temperature effect.
Okay,
Yes.
wonderful, wonderful. So you are into a new arena.
And many people, Ajit is there, he is using this fly ash and alkali and everything in soil.
Okay,
Uh, uh,
okay, okay, okay,
in
okay, okay.
the UCS, CBR, and all these things.
So we
And
are always trying to make stronger.
you see, I always say to my students that whenever you are attending any lecture, after the lecture is over, are you feeling stronger?
Yes.
As a participant, student, whatever you say, I am
Sir,
really feeling
sir,
stronger.
Yes. Yes.
sir, I'm sure that whenever we say, for example, we drink milk, whether we know the composition or not, we are going to gain weight. So we are definitely we are going to gain.
Yes,
Okay, definitely we gain.
no doubt,
The
no doubt.
composition is not important. The important is we gain.
Yes, yes.
Yes, yes.
Thank you, Dipti. Thank you.
Yes,
Thank
sir.
you.
Thank you, sir.
Thank you
Thank you,
very
sir.
much.
Thank you, sir, for your valuable time,
Yeah.
and hope to meet you again in another some sessions again.
Okay. Thank
Yes.
you very much. Thanks to
Thank
all
you.
my colleagues, sir. Thank
Thank
you
you.
very much.
Have
Thank
a
you
Thank
very
great
you.
day,
much.
sir.
Thank you.
Thank you. Sir, I'm leaving then.
Yes, yes. We are also leaving. So, Atreya, we are leaving.
Yes, sir. I will announce the for the next session, and I will leave, sir.
Okay, okay.
So, dear participants, I thank you all for your presence today. Please note that on our afternoon session will start from 3 p.m. It will be a very interesting lecture. So, please come back before 5 minutes of starting the session. Thank you again, and see you in the afternoon after lunch break. Thank you.
Professor Maiti,
Yes, sir.
good afternoon. Good afternoon.
Sir, sir, am I
Yes,
audible?
yes, you are perfectly all right. Audible. Your health is okay now. Everything fine.
Sir?
You are okay. Your health is okay.
Yes, yes, I am okay.
Okay, okay, nice. So I think now the coordinator he should start the session.
Okay.
A very good afternoon, everyone. I, Deepti Yelanki, Assistant Professor, Civil Engineering, Haldia Institute of Technology, welcome you all back for the afternoon session of third day online FDP on recent trends in civil engineering. The speaker of this session is Dr. Damodar Maiti, and the topic of this session is seismic resistant building planning and design. Dr. Damodar Maiti, Professor, Department of Civil Engineering, IIT Kharagpur, has more than 20 years of teaching and research experience. Sir has taught several structural engineering courses, including structural dynamics and earthquake engineering, advanced structural analysis, finite element method to both UG and PG students. Sir has conducted more than 10 short term courses to the college and university teachers and working professionals both from government and industry. Professor Maiti has developed two video courses on design of steel structures using working stress method and limit state method and one web course on finite element analysis under NPTEL MHRD. Sir is author of a book titled Computer Analysis of Framed Structures published by IK International Private Limited. Sir has also guided several PhD and MTech theses in the area of structural dynamics. His research area of interest includes seismic control of high-rise structures, structural health monitoring, fluid structure interaction, etc. Professor Maiti has published more than 150 papers in national and international journals. Sir has received two Best Paper awards from the Institution of Engineers India. Professor Maiti has served as scientific or advisory board member for several international conferences. He is reviewer of several international and national journals. Sir has served as secretary for the Indian Society of Theoretical and Applied Mechanics for 3 consecutive years. Sir was honorary secretary and presently chairman of the Institution of Engineers India Kharagpur local chapter. Professor Maiti is one of the technical advisory committee member of NDMA, Government of India, related to design and construction of cyclone resistant shelter. We welcome you, sir. Over to you.
Thank you very much, Dr. Deepti, for this introduction. At the outset, I like to convey my sincere thanks to the organizer for giving me opportunity to deliver a talk on system resistant building planning and design. Also, I like to thank Professor Somnath Ghosh, my UG teacher, who has been inspired throughout my life in this area.
Yes, you are audible. You are audible.
It is visible.
Yes, yes, yes.
My presentation is visible, right? Okay. So, when we are talking about seismic resistant building design, it comes along with the planning, that how the building should be planned, how its shape should be, the configuration, which will be the most uh, seismic friendly configuration. All those things will come into picture. That's why I have slightly changed the title of the topic now, which is seismic resistant building planning and design. Now, before going to details, about the philosophy of seismic resistant building planning and design, uh, I would like to inform you the wall distribution. Maybe many of you know the wall distribution of earthquakes, because first we have to know what are the chances of earthquake in our place, or what are the chances of earthquake in a particular place where the building is going to be constructed. So uh, from this world map, you can see that there are three types of earthquakes happens. That means three types of plate boundaries are there for which the earthquake happens. One is convergent boundary, where the two plates are moving towards each other, and
Professor
another
Maiti,
is divergent boundary, where the two plates are moving away from each other
Professor
and
Maiti, it is not
transform model.
visible. This slide is not visible.
Light is not visible.
No.
So you have to share entire screen. When you present it, you have to select entire screen.
I have done so.
Yes.
Okay, 1 second. Coming.
No, sir.
No, no, it will come. It will come. It will come. No problem. Ah, now it is coming. It has not yet come, but it will come soon. Ah, now it is
Yes.
coming. Fine. Everything fine.
Yes, sir.
Now it is okay. So
Yes, sir. We can see.
Absolutely, absolutely all right.
this world map is showing, na? World distribution.
Yes, sir.
Okay. Okay. So three types of boundary means are there, plate boundaries, for which basically the earthquake happens. In our country, you can see, if you see the distribution, in our country, a boundary has moved from northeast, and then the entire north area of our north region of our country, which is basically convergent boundary. And here, US plate and Indo-Australian plate are moving towards each other. One plate is going up of the other plate, and because of this, the earthquake is going to happen. Now, coming to our country, we have seen that mostly the northeast and the northern part are seismically active zone. And you see here, as per our IS code, the entire country has been divided into four zones: zone 2, 3, 4, and 5. And before Bhuj earthquake in 2001, it was actually 5 zone. Now zone 1 has been uh, means clubbed together with the zone 2, and therefore now it is from zone 2 to zone 5. And you can see that the entire northeast area is coming under zone 5. Not only that, also in the Bihar Nepal area, means north of Bihar area, and in other places in Gujarat, in some places also is coming zone 5. And basically 60% of our country's land are under moderate to severe seismic hazard. Therefore, when we are going to construct a building, we need to know and based on that we need to design the structure. Therefore, it is very important to know that in which zone the building is belongs to. And if we see our past history with regards to earthquakes in our country, you'll see there are four big earthquakes happens in our country. So you could see in 1897 in Assam, then again in 1904 in Kangra, then 1934 in Bihar, Nepal, and then 1950 Assam. Again Assam. That has been distributed means from the record, the statistical record from the past. These are the distribution we could see. So we can get some idea that where the maximum magnitude of earthquake may happen. So according to that, we have to make our building safe. Now, before going to the disaster management, because of ground shaking and depending on the magnitude of the ground shaking, some disruptions of utilities may happen. Some non-structural members may fall down, or if the magnitude is little high, then the structural members may fail, and then also the entire building may collapse depending on the magnitude of the earthquake. And because of earthquake, aftershocks may come into picture, for which again some tremor will come, and water table adjustment may happen. And indirect effect that we can see that one is the landslide due to the ground, also ground failures, and then elevation means drop of elevation of land due to removal of water, which is called subsidence. And another important effect we used to get, that is liquefaction. And because of liquefaction, some building may fail. That also can happen during earthquake. Because during liquefaction, what happens? That strain in soil gets reduced because of its saturation. It acts like a pillow, elastic pillow, for which the soil gets zero strength almost, and because of that, building may collapse. And another indirect effect we all know, after 2004, that tsunami, Andaman and in South India, means in Chennai area, we have seen a lot of tidal waves because of tsunamis. So this is another direct effect. In fact, in Japan also, a big tsunami came, because of which certain losses have been happened. And because of earthquake, flooding may come into picture, fires from electrical may happen. So these are all the indirect effects for which we have to suffer. Now, before going to the philosophy of earthquake building design, earthquake resistant building design, we can see some previous failure from which we can learn. Uh, Say for example, the Pine Gout Corporation building uh, in 2011, it was collapsed due to earthquake, and you can see the before earthquake and after earthquake. And from the picture before earthquake, you can see the ground floor was actually soft story, and there was overhang. Enough overhang was there. So those who are designing, we know very well that soft story is dangerous during earthquake. So we have to take some extra precaution. And also we know that overhang portions are dangerous. So we need to reduce overhang as much as possible during design. Otherwise, we have to take some extra precaution so that the overhang doesn't be a problem. But because of the presence of overhang and soft story, building has collapsed like this. This is in New Zealand. Another picture I am going to show, that is happening in this Sikkim earthquake in 2011. You can see from this that the overhang portion was totally collapsed. This was also certain overhang portion. Uh, Example very frequently people used to show, that is the earthquake. Due to earthquake, the buildings collapsed. Collapsed means just tilted because of the liquefaction. So here you can see the structural failure was not there, but because of the failure of soil, that means because of liquefaction, how the buildings are tilted and finally unused means we are unable to use. That is a typical example. This is the Dharahara Tower in Nepal. It is collapsed in 2015 year of earthquake. You can see here that from the debris you can see it was made of lime and surki. There is no reinforcement, nothing. There is no cement. So it was basically brittle in nature. So it has been collapsed totally. Same thing for Darbar Square in Nepal. In the same earthquake, it has been collapsed. So before and after earthquake is shown. So that the buildings are going to be affected if certain mistakes we have done, if certain limitations we have made in our design, then only buildings will collapse. At the same time, you can see Yokohama Landmark Tower, which is 70-story height, doesn't happen anything to this building. Even the last year's earthquake, March 2022, with a magnitude of 7.3, it hits, but nothing happened to this building. That means technology is available. We are not applying that technology properly. As a result, we are suffering. So if we know the appropriate technology and if we follow the oral provisions, whatever given, if we follow the earthquake resistance design philosophy, then definitely there is no chance of failure of buildings under earthquakes. Now let us come to the earthquake resistant design part. So before design, you can see that what are the forces comes into picture in earthquake. Basically, in earthquake, the inertia force dominates, and inertia force, because of inertia force, some lateral forces are developed. In left side, you can see because of the inertia, how lateral forces can make the building vibrate. Okay, and because of this inertia, the forces will be laterally acting, as well as if the ground motion is vertical, then along vertical also that inertia force will act. And in case of wind, you can see that the same type of lateral forces comes, but it is much more at a higher level, and then it goes down, right? And its deformation will be like this. In the right side, you can see that how the deformation happens because it is fixed at the ground level, right? Looks like a cantilever beam. So, though in both the cases, lateral forces are coming into picture, but their magnitude will be different, their type will be different. Type means one is due to inertia, another is due to pressure. So, when we are going to design, we have to find out what exactly lateral forces are coming to the buildings at different height. Right? So in case of ground vibration, we know that three types of earthquake happens in three directions, and its nature is basically random, and it happens only for few seconds, maybe 30 to 60 seconds. It generally stay, right? And since the direction of the earthquake is random in nature, so it may happen in any direction, means x, y, z, any direction. So generally what we do, we make means earthquake component into three principal directions: x, y, and z. So two horizontal and one vertical component can be found from any earthquake vibration, and then according to that we have to design. So if vertical vibrations happens, you can see how acts, so there will be a vertical inertia force, and because of which it will add the gravity force and subtract the gravity force depending on the direction of motion, because direction will be in both the side. So sometimes it will add, sometimes it will subtract. Okay, but the gravity means the vertical vibration will not create much problem, because of its the gravity load of the building, and we know concrete is very strong against uh, compression. Therefore, uh, due to vertical vibration, generally we avoid to find out the seismic forces due to vertical vibration, because we know that because of vertical vibration, the load whatever will come, that will either deduct uh, from the gravity load, which will be less, or if it adds, then the compression will happen, and compression will not create problem because of the strong strength of the material. Material means basically concrete and as well as steel, and also we have enough factor of safety in design. However, for horizontal vibration, it creates problem, because in case of horizontal vibration, what happens? Certain moment will come into picture, certain base shear will come into picture, and as a result, we need to consider these horizontal vibrations properly, and then we have to find out the forces and its consequences. So we need all those things. So during horizontal vibration, we know that one inertia force comes into picture horizontally, for which the lateral forces will be generated, and also we need to know the vertical load transfer of the building. Load transfer is continuous. Load transfer of the building system should be continuous, and also adequate strength is necessary to withstand that much forces, right? So coming to the philosophy of earthquake resistant design, what are the philosophy we should consider? That one is the structure should be able to resist minor shaking with no damage. That means we will design the building in such a way that under minor shaking there should not be any damage, and under moderate shaking there may be some non-structural damage, but there should not be any damage of beam, column, slab, foundation, basins, and many other things like shear wall, etc. And for severe ground motion, which is very much infrequent, very much less, uh, will allow some structural damage, but with no collapse. That means for severe damage, the design has been considered in such a way that for severe earthquake, the design will be considered in such a way that there will be structural damage. That means we will allow structural damage, but we will not allow collapse. So under no circumstances collapse should be allowed, because we need to save the life and property inside the structure and also adjoining to the structure. Therefore, these few things we have to keep in mind, right? So when we are going to make a earthquake resistant design, we need to make the design in such a way that will allow certain structural damage in case of severe earthquake, but will not allow any collapse. And also, in case of moderate earthquake, we will allow some non-structural damage. Okay, how it is possible to make it, that will show in next few slides. I will show you. Now, here some records I am showing, that is magnitude versus approximate number per year of earthquakes. So every day, every minute, certain earthquakes are going to happen, in certain places, particularly the region where the plate boundaries are there and where the zones are seismically active. Right. So with magnitude 1, you can see around 7 lakhs earthquake happens per year, whereas with magnitude 8 and above, one in every few years, not in every year, one in every few years. So we can see here that it happens very, means the severe earthquake happens uh, very less. Even you can see 8 and above occurs only one in every few years, and around 7 magnitude occurs 50 number per year. So why I am telling? Because from this we can understand that the earthquake means seismically inactive zone, means less active zone, can be considered for designing building in such a way that we can make cost optimized. That means there we have to make the building very strong so that it can withstand the earthquake forces of severe magnitude. But in many places the magnitude is very less. So for that we have to design accordingly. So for seismic resistant design, there are 4 aspects which we need to keep in mind. We have to ensure the strength of the material, quality of the material. Say for example, we are going to make say M25 grade of concrete. We are going to construct the building with M25 grade of concrete, and design has been done in such a way. So that we have to ensure, because if it is not M25, below the M25, then definitely strength will be less, and as a result the structural failure may happen. Therefore, for seismic resistant design, we have to ensure the design strength. Means whatever the design has been done, that strength has to be ensured during construction. So quality of concrete has to be maintained at the site. Next is the stiffness and design aspects. So design has to be done zone, means which zone and the building is going to be constructed. Based on that, that design methodology has to be followed, and also we have to see the stiffness. Stiffness has to be properly made of the structural members so that the displacement doesn't occur much. Because if displacement occurs much, then what will happen? Then there will be a problem of serviceability. So discomfort of the users will happen, serviceability problem will be happening. Then the cracks will come into picture because of large displacement. So those things will be there. So therefore, the stiffness has to be made, means horizontal stiffness as well as vertical stiffness has to be made properly, and there should not be any stiffness jump, because in case of stiffness jump there is a scope of failure at that boundary, means with low stiffness and high stiffness at that joint, and there will be chance of failure. So that has to be ensured. Another aspect we have to consider, that is ductility. Ductile means the structure has to be ductile. Ductile means the member has to be ductile as well as the structure, the system has to be ductile as a whole. So the detailing of the members have to be done properly, because through detailing we can ensure the ductility. And we know the RCC member, concrete member, reinforced concrete member, are generally brittle in nature with respect to steel. So if we make detailing properly, if we try to make the joint monolithic, then the ductility can be ensured, And because of ductility, the building can be made seismically resistant. These first three are the structural engineers aspect. The structural engineers has to see, and there is a job of architects as well. They have to keep in mind that the configuration and planning aspect. In this sense, if our planning is not proper, then there is a chance of development of stress at different level, and there is a chance of concentration of stress at different places. There is a chance of torsional moment at different places. So configuration has to be proper, and configuration means basically beam column layout has to be regular, and it has to be continuous in nature so that the stress concentration doesn't occur. Also, planning has to be made properly. So configuration means one is geometry, and then size and its shape, right? So these three things has to be considered, and then location and size of structural elements means at which though non-structural elements are not taking any earthquake forces, not carrying any earthquake forces, but it has effect on the structural elements. Therefore, the location and size of non-structural elements also is important. This is a typical example. The building get collapsed during Nepal earthquake, and it is because of the poor geometric configuration. You can see at the left side, uh, there is means the geometry was not proper, and haphazardly the buildings have been planned. It has been done, and right side you can see that overhang was shape of house. Let us come to this that that in practice site of the building means where the building will be considered that site available site are generally not rectangular or square. Each size are haphazardly available and with different types. Okay, and builders or the owners wants to utilize the entire site or as much as possible. So based on that, the architects used to make plan which becomes actually irregular in nature. And because of irregularity of the shape of the building cannot be made earthquake resistant. So during earthquakes, its behavior is ill, and because of that, it right. So for example, you can see here. Say for example, if the building shape is becoming like U shape or C shape, and building shape may become L shape, H shape, and also a narrow rectangular shape, like different type of shapes come into picture. So if the vibration occurs, lateral vibration occurs of such type of building shape, then what will happen? The torsion will come into picture because it is a entire shape is not symmetric, and if it is symmetric also some haunches are there in some places. So what will happen? All these corners etc. The torsion will develop in the picture depending on the direction of the earthquake. So lot of means if we want to make this type of building structure to make earthquake resistant, then what we need to do? Either uh, we have to introduce lot of steel to take care the torsional effect and other things, or we can induce some separation gap. So one good solution is for such type of building configuration is that introduce some separation gap. If we introduce some separation gap, then what will happen? The individual block will vibrate separately. So one will not affect the other. As a result, its what do you call its base shear and other forces will come less. Uh, okay. So separation gap has distinct advantages. We should take those advantages in making the earthquake shown that the rectangular shape when the length is to width ratio of the building is more than 3, then we must provide some separation gap. Okay, otherwise what will happen? In one direction it will be very less, and in other direction rigidity will be very more. So the lesser direction rigidity having the lesser direction uh, may have chances of failure. Therefore, it is better to make certain separation gap of a rectangular shape having length is to width ratio more than 3. Okay. Here I have shown that I shape or H shape building, if it is there, then how to make separation gap, or for L shape building, how to make separation gap. This is a plan of a building. In fact, this I have taken from paper, means they have given advertisement of this plan for a flat, right? So I have just take a snap of that and I have shown here. So this is the reality. Reality means, you see, we know very well that the beam column layout should be regular as much as possible, and the load path should be continuous. Load path should be sorted load path, generally the energy flows. So we should make the load path in such a way that energy can flow in the shortest direction, right? But if you see here, there is no load path horizontally. The beam columns are irregular. Haphazardly they have made based on the requirement. Plan, if it is done, then definitely it will be very difficult to make seismic design. Basic grammar of making seismic design is that beam column layout should be regular in nature. So though it is known to engineers, means those who are learned engineers, it is known. It is told in the oral provisions. Uh, in many places it is available, but architects and civil engineers do mistakes without knowing or knowingly, like this. Right. So if you move around in your city, wherever you're staying, you can find out such type of buildings are being constructed or are constructing regularly without following any grammatical consideration. That beam column layout should be regular, and many other things are there. This is one of them. So plan should be regular, like the right side, whatever I have shown. A beam column layout as much as regular it should be, and the load path, both vertical and horizontal, should be there, so that load can be uh, distributed continuously from one place to another place. So if load path is not continuous, means what? Say for example, this building left side, you can see the overhang is there. So during earthquake, what will happen? I do is in city and town, you see most of the buildings are done like this. That overhang portions they have made, columns are inside, and overhang portion they have made, and in that way they are constructing the building. But If it is constructed like that, then there is a chance of failure of that overhang portion. Load path is not maintained. What it should be like this, that column should be outside, and so that the load path is maintained, and there should not be any overhang portion as much as possible. But if overhang is there, definitely we can make it earthquake resistant, but we have to take care of those portions additionally. We have to make detailing, structural detailing properly. We may need to provide certain additional steel there portion so that the overhang portion behaves properly during earthquake. Open story or ground, which is called soft story. Now you see in 2001 Bhuj earthquake, the pictures have been shown here. The consequence of open ground story for RC frame buildings. Right, you can see the ground story are simply collapsed. Ground story has been simply collapsed. And in right side also you see the, because of open story, because of soft story, the column portion at the bottom level, means at the ground level, has been affected severely. Right. So another example has been shown here, that collapse of open story during Nepal earthquake in 2015. The simply collapsed of the ground floor. It happens because you see, apart from ground floor, means that apart from open story, other stories stiffness are comparatively high because of the presence of the non-structural member, that is brick masonry, brick wall. Actually, brick wall we do not consider as a structural element. However, brick wall has certain stiffness, which offers stiffness, lateral stiffness as well as vertical stiffness. Therefore, what happens is, because of the presence of this brick wall, the upper portion of the ground floor will be so what will happen? There will be stiffness jump between two floors, between ground floor and first floor. Okay, so it may fail because of this, right? So ground floor columns has to be designed properly so that failure can be arrested. How you will do? There are different ways to overcome this problem. One is that the dimension and reinforcement of ground floor columns should be higher than the other floor columns. Right. I have shown in the picture. You see the column dimension is less beyond ground floor. Only in the ground floor the column dimension will be more. In this case, what will happen? The lateral stiffness of each floor will be similar. There will not be any jump of the lateral stiffness. Right. So now question will come that how do I calculate the lateral stiffness of this brick wall? In fact, Professor Sudhir Jain and Professor C.B.R. Murthy have published a paper from IIT Kanpur long back, that how to calculate the stiffness of the brick wall, considering some truss, truss member. They have provided some diagonal truss, equivalent diagonal truss having certain stiffness. Right. So if we consider that method, then we can take the effect of the presence of brick wall, and then accordingly, if we can model in the software, then we can find out what sort of dimensions is required at the ground floor level. Because from that we can find out what are the forces are coming at the ground floor level and what are the forces are coming at the other floor levels. So based on that forces, we can design the column. So after designing the column, it may look like this, that the size of the column will become more at the ground floor level and uh, less at the other floor levels. Also in the code, it has been mentioned that how much additional force we should take for design of ground floor. From codal provisions also, one can make the design of ground floor. Other option to make stiffer of the ground floor column is that provide a horizontal band, lintel-like band at the ground floor level. Provide, then what will happen? The stiffness of the column will increase, because we know stiffness of the column. How do we calculate it? You can remember the 12 EI by LQ. So if L become less, this will become high. Okay. So if I can make the effective length less in the ground floor level column properly. This is one way, but not the right side one. Right side one, if you see that in one place we have made stiffer, but not in other places. So this is dangerous actually. You should not consider this type of things. Other way of uh, overcoming this problem is to provide some bracing. We can provide some bracing like this at the ground floor level, so that the ground floor becomes steep as steep in the upper floor levels. Another important note we have to consider, that is the design should be on the basis of strong column with beam. But in practice, if you move around your surroundings, you will see in many buildings column size are less compared to the beam, because beam, the generally beam depth are more. So finally you will see the beams are becoming strong than the column, right? So if we consider weak column, strong beam, what will happen? That during earthquake, first column will collapse, right? So during earthquake, first collapse, not the beam. So what will happen? If column collapse, means entire building will collapse. But if we consider strong column with beam, then what will happen? That first the beam will collapse. If beam collapse, what will happen? That floor will be affected, but not as a whole the building will be collapsed. Right. We should consider the design in such a way that it should become strong column with beam. Right. Of strong column with beam, and with beam strong column. Sorry, strong beam with column have been shown. The right side, if you see the strong column with beam, so the plasticity occurs at the beam level. So first beams are going to be affected, and strong columns are not being affected. Columns are remaining same. Horizontal band. You know that particularly for masonry structure, we have to provide certain horizontal band at a certain level. Generally, we provide at the lintel level. For masonry structure at the lintel level, in place of providing cut piece of lintel, means small pieces of lintel, what we should provide is the continuous horizontal band throughout its periphery. Right. If we provide that, then the building will be much more seismic resistant. Right. Generally, in case of RCC structure, what we provide is the provide a horizontal band, means continuous lintel we used to provide, not the cut piece. Okay. Here, one example you can see here, that collapse of unreinforced masonry building, because there was no lintel, nothing. So resist this. If we provide lintel, then then another way of encountering seismic forces is to introduce shear wall. Actually, if we consider moment resistant frame, then there will be a large displacement. And for large displacement, what will happen? There will be a discomfort of the user. Also, for large displacement, concrete cannot take more displacement, so there will be a crack. Maybe non-structural crack, but cracks will happen. But if we restrict the displacement by the addition of shear wall, then that problem can be solved. And how do we provide the shear wall? You see at the left one, this is unsymmetric location, but this is not desirable. If we provide unsymmetrically, its behavior will not proper. I mean, in some places, certain forces will develop, and for which the cracks and other sort of failure will come into picture. In fact, the another picture at the top right, you see, in one direction only the shear wall has been given. That means in one direction the displacement will be will be taken care, but in other direction there will be a large displacement. So what we need to do, we need to provide in two direction and symmetric as much as possible, in symmetric location. So shear wall should be inserted symmetrically as much as possible, so that building's behavior gets proper, and additional abrupt forces doesn't occur in any place. And to mitigate that, we can provide the shear wall properly. Another aspect is the ductility. Structural ductility has to be ensured. You see, we know what is ductility. Ductility is basically the ultimate displacement by the yield displacement, right? So in figure you can see that up to yield there is a displacement. After that, nonlinear response actually happen. So an idealist we have done. So finally, ductility can be calculated by the ratio of maximum displacement or ultimate displacement by the yield displacement, right? And from here you can see if the ductility is more, that means mu value is more, then the ultimate displacement is more, then the energy stored by the element will be much more higher. Energy stored by the member will be much more higher. Therefore, during earthquake, energy can be stored on those for the ductility aspect. Okay, so ductility has to be ensured in different way, and the ductility can be improved by properly reinforcing the uh, steel rods, and also by properly detailing, making detailing of the reinforcement. That can be found in the codal provisions. I'm coming there. And before that also, let me show you. Generally we do singly reinforced beam, but if you make doubly reinforced, then what will happen? The ductility will increase because the curvature is going to increase. Here you can see one result that PC is the percentage of compression reinforcement. That means at the top, PC. Then its curvature is very less. On the solid line, that means its curvature is very high. That the moment curvature relation with the increase of percentage of compression reinforcement. So to make the beam member ductile, we should think of providing doubly reinforced member. If you make the beam doubly reinforced, then it will be ductile. Other ways of ductility means overall structural ductility has to be ensured. We have to see what is the base shear and roof displacement. Then story ductility, interstory drift we have to find out, and we have to ensure that. Then member ductility, that means force versus displacement, which we have shown, and the section ductility, the moment versus curvature. Moment versus curvature is this one. So different sort of ductility can be introduced in the structural system so that overall behavior of the structure becomes better during earthquakes. Another aspect we should consider, that is lateral stiffness. Actually, sometimes we do not consider the lateral stiffness. We just consider the strength part of the structure. But if lateral stiffness is less, particularly during earthquake, then failure of the structure may happen like this. Here you can see the because of the less lateral stiffness, the structure was failed. And because of less lateral stiffness, what will happen? Large deformation will occur, and because of large deformation, it will get inelastic response, and because of that, damage may occur. P delta effect may come into picture, for which damage may come. Also, non-structural elements may damage because of large deformation, and discomfort during vibration. Because of the less lateral stiffness, vibration will more, so the user may feel discomfort. Now, as I was telling, that ductility can be in our Indian code, that is IS 13920. In IS 13920, that how beam column should be detailed, that has been shown. Here you can see that at the beam column junction, the lateral ties, the transverse reinforcements are more densely spaced, right? During at the beam column junction, if you see, okay, and it has to be up to 2D from the column face in both the side, okay, and the spacing of stirrups will be calculated, and it should not be more than d by 4 and 8 times beam bar diameter. D means depth of the effective depth of the beam. Okay, so that has to be mentioned, and in the middle side it should not be more than d by 2. Now column means the beam column junction across the height as per the IS 13920 as it's shown. You can see here how the reinforcement from beam has been extended to the column when beam is in one side. At the top left you can see, right? So joint reinforcement has to be done properly based on this codal provision, and you can see here when splices are used at the splice level, the transverse reinforcement will be more. That will it is given in the clause 7.2.1 means in the clause itself it has been told, right? So the confining reinforcement at the joint level, how to make, all the details are given. Only thing is the engineers are not following properly. So if we know the consequences of this, then definitely we should provide. Another aspect is that sometimes we bend the beam bar at the joint level, which will actually overstress the concrete at the bend portion. Okay, so generally the lower portion, if you see the picture of the lower one, uh, this type of thing should be done, and generally we should make the beam width little lesser than the column width, so that we can make it possible like straight we can provide. So in fact, IIT Kanpur BMTPC has given uh, some know-how and some tips they have given, that how the detailing should be done, what should the hook length, what should be the bend degrees, how much degree should be bent. So all these things have been given properly. It is available in the code also, but if you go to IIT Kanpur BMTPC site, there around 25 tips, 25 number of tips they have given. So with some detailed discussions, they have given the tips. So we should try to follow those things, and we should try to read those things so that when we are designing the building, we should be aware of that facts, right? So here you can see the shear failure of the column when the spacing of the stirrups are not sufficient. Also, you can see the diameter of the transverse bar and diameter of the longitudinal bar is transverse bar is quite less than the diameter of the okay. So these are the things which we need to know. Then I will discuss little about the facts that what we should do during earthquake. So during earth means the building should be designed in such a way that building will be safe during earthquake. So we have to make the proper plan of the building, proper design of the building, so that we get confidence during earthquake that no, nothing is going to happen, right? But we, the Indians, do not have confidence on the buildings which are existing till now. And as a result, what happens during earthquake, we generally come out from the building and so when some earthquake comes into picture, when earthquake happens, the general picture is that all people come out from the building and rush haphazardly and try to save themselves. But they do not know that during earthquakes means the earthquake happens only 30 to 60 seconds. So during this 1 minute, it is very difficult to come out from building to a open space, because open space in city is not that much available. Number one. Number two, in a multi-story building, it is not possible to come out by 60 seconds to the ground floor level. So what happens? Generally, they get so this is a common picture. You can see that during earthquake, people used to come out from the house and stay outside. This is one picture when some earthquake happens in Assam, and in Siliguri, in one school, all school children come out and they are waiting outside and they are studying. Okay, and they feel they are safe under the sky, not under that building. Okay, so what we should do actually during earthquake? What we should do? Now this table I have shown with a greater magnitude. Okay, and worry much during an earthquake that our building is going to collapse, because if you see the statistics, how many buildings are collapsed? Not much in during earthquake, right? So what happens actually? Because it happens that the non-structural members fails, the utilities got disrupted, many. So first thing is we have to think that during earthquake, can we become safe by coming outside? Because if you want to come outside, you have to come by stair, and stair is the most vulnerable element in terms of earthquake. Okay, so there is a high chance that you got trapped in stair during earthquake. So better not to move around, um, means not to move from the building. Rather, let be quiet and stay inside building with some protection. Okay, here you see the stairs are damaged by this Department of Earthquake Engineering, IIT Roorkee and Rajiv Gandhi Foundation, New Delhi. They have suggested certain things that during earthquake, please be calm, stay away from glass windows, doors, almirahs, mirrors, because from falling plaster, bricks or stones. Okay, because the minor earthquakes frequently occurs, and because of minor earthquakes, such type of uh, things may happen like plaster can fall or brick, some brick which are loosely connected that may fall. Okay, almirahs, mirrors, etc. may fall. So this can happen. So we have to be careful to protect ourselves against those things, right? So suggestion is that get under a table or a study cot so that you are not hurt by falling objects. Well, mostly people get hurt because of falling objects. And do not rush towards the doors or staircase. They may be broken or jammed. So those things we should not mean we should not rush towards the doors. And if open space is available nearby, go there provided you can go. Means if you are in ground floor, then you can go there. But keep away from tall chimneys, balconies, buildings, and other projections. In fact, if you go to the open space also from nearby building, you may get hurt. So that also you have to be careful. So during earthquake, we need to think that what we should do, whether we rush from building or we stay inside the building and we protect ourselves by going under table or cot, right? Because if you see the statistics, the large earthquake hardly comes. Chances of large earthquake is very less and chance get hurt. Okay. And another point you need to see that if a severe earthquake happens, then chances of building collapse is there. But it is also true that it is very difficult to come out from the building. And also if you come out from the building, if that building or nearby buildings collapse, you will get hurt. Because from nearby you will also be getting hurt. Okay. So after earthquake, what we should do is after earthquake, these are the suggestions they have given ITWiki. The check if you or anyone else is hurt, use first aid at least on the cuts and bruises. Shoes to protect your feet from debris. Battery operated radio can help. Then be prepared for more shocks. This is important. This is called aftershocks. So be prepared for aftershocks. Don't be panic because aftershocks will come. Then turn off the gases. Do not waste water. These are suggestions they are giving. Do not move the seriously hurt people. Sorry. Wait for medical help to arrive. Do not spread rumors. Okay. Considering all these, we need to make a strategy to make capacity building for earthquake preparedness. So what we can do, we can make a preparedness plan at the grassroots level. We can make enough awareness among the common masses. So public education on earthquake disaster can be made. Then we can enhance the national capacities for the development and implementation of the countrywide framework for disaster risk preparedness, management and mitigation in education sector. Then safety measures must be incorporated in all type of structure. That means the existing structure which are available, we must retrofit those properly to make them safe against earthquake. Existing bridges and buildings needs to be retrofitted if required, ensuring construction of earthquake resistant buildings at the administrative level throughout. Administration has to ensure that the buildings are made earthquake resistant. Seismic safety needs to be highlighted in the design itself. Okay, what are the safety factors they have considered in the design, that has to be highlighted so that people can know, the owner can understand. States can adopt the national codes or make their own codes specific to that particular region. Fixing of responsibility of adhering to the building codes and norms. Then hospital safety may be given top priority. So building and equipment of hospital guidelines frame out, which is framed out by MHA, need to be followed. Facility for stockpiling of relief material at the district headquarters should be created. The authority should have a protocol to manage the relief material. Assistance of various NGO can be sought. Simulation or mock exercises can be carried out. Where all the concerned functionaries will need to disseminate the preparedness plan, like we need to involve media, both electronic and print, for disseminating the preparedness plan. Advertisements related to disasters prior, during and after may be given in the media, and mitigation and radio and other channels at peak time of news. These advertisements can be region specific and disaster specific in different local languages. Okay, so with this, that from the worldwide map of the seismically active zones, we understand that earthquake will come frequently in different places with less magnitude or high magnitude. So earthquake will come definitely. So we need to, because if something happens after that, we feel sorry, we can feel sorry, but we were not so safe. But better not to feel sorry, better what we can do, that we can make our building safe. So let us prepare ourselves for future earthquakes, and let us try our best level that we will give confidence to the people that no, we civil engineers have made building earthquake resistant, so you be comfortably stay inside during earthquake. With this, I thank all of you, and if you have any queries, questions, you are welcome to. Thank you very much.
Thank you, sir. Thank you, sir, for your informative and interesting deliberation on the topic, seismic resistant building planning and design. We, the faculty members of Haldia Institute of Technology, as well as all our participants, are very happy and overwhelmed with the session. Professor Maiti has discussed important points and aspects of earthquakes. In this discussion, Sir has discussed direct and indirect effects of earthquake. Sir emphasized on lessons learned from the previous earthquakes. Sir discussed about the philosophy of earthquake resistant design, seismic configuration, shape of the house, and their effect. Sir has pictorially represented how load path how load path should be, and clearly what should we do during and after. Sir explained about the requirements of earthquake preparedness plan and public awareness on the earthquake disaster. Of all the discussions, the weak beam and the strong column was something I personally liked very much. I think this detailed discussion will help our participants to enhance their knowledge in seismic resistant building planning and design. Um, so your presentation was very well organized and detailed, very in a very understandable language, and with all the real-time images, we could actually understand what happens during and after the earthquake. So again, on behalf of the organizing committee, I am thanking you, sir, for this important discussion. Thank you very much, sir. Now I would like to pass on to Dr. Atreyi Bandyopadhyay. Sir, you want to say something?
Yeah, yeah.
Please proceed.
No, let Atri take over.
Okay. Now I would like to pass on to Dr. Atreyi Bandyopadhyay, who will be asking the questions posted by the participants in the YouTube chat box. Over to you, ma'am.
Thank you, ma'am, and thank you, sir, for your wonderful and so much interesting presentation. Now, for the question and answer session, I would like to invite our faculty members in house and sir also, who is also seem interested to ask you something. So, please, sir, please continue with the question. Thank you.
First of all, I must, acknowledge that that Professor Damodar Maiti has given his valuable time to HIT and delivered a lecture in a most lucid way. And I think those who are not that, familiar to earthquake resistant design, uh, they should be able to start at least, because uh, whatever research you do, before that you should know about the subject, at least the overview, and that is, Professor Maiti has given in the best possible way, because starting from the planning part of it, after that, the preparedness, everything, and as a whole, he has given a bird's eye view, and that is sometimes for a particular faculty or any professional, gives you, you know, a tremendous advantage of, uh, you know, going into the subject in detail. And of course, after that, you can always ask the experts that I want to do it this way, or I am not understanding this. Please let me know this, because nowadays everything is, email, uh, Google Meet, everything is there. So I must, I'm really grateful to Professor Maiti. Uh, Now, Professor Maiti, I have got some, questions that, can you
Sir,
listen?
I am very much grateful to you for giving me opportunity to share my experience here. I'm
Uh,
very much grateful to you and HIT.
Thank you. So, Maiti, that regarding the seismic behavior of a, um, you know, particular structure, it may be a building, it may be any kind of other structure. at least I can say that, the sentence which you have uttered, that if somebody can design a building properly, following code, then almost 95% is achieved almost. Because, but
Yes,
unfortunately, not only in our country, but also in other countries, I have seen in the newspaper, during earthquake, I don't know how many hundreds of buildings collapsed in a particular country, and there the report came out that nobody is following, you know, earthquake resistant design rules or the guidelines. That is
yes,
happening outside our country also. Now, it is better now in our country. At least you have to certify that it's a earthquake resistant structure or a building. But still, then I must tell you that in most of the pockets, uh, even they don't care about IS 13920, IS 4326, and they design it. Even sometimes they don't consider earthquake also. So this is the problem in our country. Still, we have, and we have to convince people in a better way. You talked about liquefaction. Yes, after a long time, IS 189 2016, they have, at least given many methods, how to get the liquefaction potential and all these things. But still, still there are many areas where we have to educate people, and we have to also learn more. We have to do uh, much more research. So I think that this is the beginning of a particular subject today. Maybe in future we will take up the topics separately, one after, and there, if we go for a group discussion or a mono lecture, we can do it, and that perhaps that will help or enrich the knowledge of the participants. And frankly speaking, IIT Kharagpur is very close to HIT, and with my experience in last 1 year, uh, you know, I sometimes feel that HIT is mini Jadavpur University. This environment is not like, you know, what can be comparable to any other private college. Uh, Here, there are many persons in physics, chemistry, your chemical science, and also civil mechanical. They are working together, and which you have seen in IIT in Jadavpur, and in my department, civil engineering, we are around 20 faculties, and they are, extremely keen to do something, extremely keen. And uh, I am sure that if we help from IIT Kharagpur, from persons like you, then the progress will be faster, and they will be able to make a mark on this earth. And yes, we have produced something, and why not? If we do work jointly, we can come out with patents, and this environment is there. So sometime I'll request you to come to HIT and meet faculty members directly, and maybe in a discussion you can participate. So I'm really happy. Many thanks to you.
thank
Right?
you, sir.
Thank you very much.
Thank you. Come to HIT to meet all the faculty members. And also, sir, regarding this, I will request if HIT can take part of making some short-term course, means in physical mode, to the engineers, PWD and other engineers on earthquake resistant structure. Because you see, technical know-how is there, knowledge is available, but people are not implementing. As you rightly said, that not only in our country, in other countries also they are not implementing. But being a civil engineer or being a responsible citizen of our country, we think, means since it is available, since knowledge is available, we should disseminate the knowledge to others, so that our buildings become safe in future. So if you sir take initiative
Yes,
to
yes,
make some short-term course to the engineers, to
yes.
working engineers, that will be very
Practice
good.
engineers. It's
Practice
a,
engineers.
it's a fantastic advice. I am readily, I'm
My
accepting it.
request and suggestion.
I'm readily accepting you. And uh, as you are 100% correct that sometime offline mode is better than online
Offline.
mode. And let us start, that. And maybe initially we can make it 2 days, because what is happening, that if we call them for 5 days, then the company is not allowing them to come. So 2 days crash course means
Yeah, that,
that
yeah.
that may be helpful initially, and later on we'll see if we get better response, we will design accordingly. Thank you very much. Thank you. Thank you.
Thanks. Thank you, sir. Thank you.
So Atri, can I leave?
Sure, sir. Thank you, sir. And thank you, sir, for your wonderful contribution. Anyone from other faculty members is interested to ask anything to sir? Please go on. Let's
Uh,
see. I think everyone is contented with the session. So some participants have questions. So may I ask, sir?
yes.
Sure, sir.
Acha. Okay, thank you, sir. The question is, while designing the structure for earthquake effect, what assumptions should we choose for the floors to act as individual rigid diaphragms and sway during the earthquake movement?
No, rigid diaphragm, you see, in any software you can find out that option of rigid diaphragm is there. So if you consider the rigid diaphragm, then rigidly it will behave along the horizontal directions. Ah,
Okay, so okay,
the analysis can
okay,
be done.
and okay, and the next question is it required for the strong columns has to be more ductile in this case than ordinary RC building column?
No, he has answered already that
No, no, no.
strong column, weak
Get,
beam,
so that
and he has already given the requirements for ductility. He has
Yes,
already
sir.
shown the code that
Yes, sir.
regarding ductility. You have to
Yes, sir.
follow.
Okay, sir. No, so the question is that means for the strong column compared to the ordinary RC column, the comparison they are asking. I think. Yes, sir. It is just like that. Okay, sir. Let us.
No, no, no. I think the question is a bit confusing, because
Yes, sir.
if you follow IS 1329,
Yes, sir.
IS 1320, or IS
Mhm.
4326, what he has explained nicely,
Yes, sir.
then it is expected that it is a ductile design. If you don't
Yes,
follow,
sir.
if you follow only IS 456,
Yes, sir. Then it will be confusing.
it is not ductile. So
Hmm.
you have to choose, or
Yes.
your client will force you to use that those
Ha.
codes.
Yes, sir.
Uh,
Yes, sir. Thank you, sir. These are the questions only. Thank you, sir. Thank you, sir, for your valuable time and your wonderful elaborative session. Thank
Thank you
you
very
very
much.
much, sir. Thank you, sir. Have a great day ahead.
Thank you. Very good.
So, this is how we end our wonderful and beautiful session. All the participants, thank you for being present in this session, and hope to see you again tomorrow at sharp 11 a.m. for our tomorrow session. Have a great day ahead.
Goodbye.
So I am leaving. Okay, thank you, sir.
Thank you.
you.